title from the first page when you're issuing the reporting the results, your test report or calibration certificate, it should be the title of that particular things. The name and address of the laboratory for which you are doing the work or which you are issuing the certificate, that should be clearly understood on the certificate or test report. The location of the performance of the laboratory activities, including when the performance at the customer's facility or at sites away from the laboratory, sometimes facilities or in association with temporary or mobile facilities. So you should clearly tell us where you have performed the experiment, and if it is a site calibrations, then you have to make the location, because in many places calibration becomes null and void when we go that our universal testing machine or UTM is standing in the workshop. When we visited, sometimes the machine was shifted to some room, so it becomes the calibration null and void. So location is very, very important when you put in the your test report or calibration certificate. So that is the most important thing. People generally forget about the locations. So sometimes deliberately we have to issue the NC non-compliance on this particular issue in all these certificates mostly. So location is the most important one, and when you're doing the dedicated to site or mobile, it should be very important the location. Location you have to put in the certificate. Unique identification of its components are recognizing as a portion of complete, reported as a clear identification of at the end. So you have to mention the unique identification number. You can make any report and you have to make clearly understood how you make it. So nobody can copy it or nobody can make an issue unique identification number. But there is no hard and fast rule how do you make it, but it should be clearly understood. You can start with your company initial, then number, something like that, then year, some financial year or something like that, you can make it. But it should be uniquely identification number on the your test report or calibration certificate. The name and the contact number of informations of the customer, identifications of the method used, descriptions unambiguously identified, and when necessary, the condition of the item received. So generally we say the received that of particular item or sample, then we says yes, what is the condition at the time of receiving. Some people are good. Generally people, 99% people write good. They never use better or excellent. So if you're receiving the things in very better packed way and other things, please clearly mention excellent also. But normally the philosophy is that people are putting good when they're receiving the things. The date of receipt of the test or calibration items and date of sampling were the critical to the validity of application of the results. So sampling, it is very important. The date of sampling, so that is very important. But date of receipt, when we writing what is the condition, then you have to write date of receipt and the dates of performance of the calibration activity, date of calibrations, when you have performed the calibrations, date of issue of the report, reference to the sampling plan and sampling method used by the laboratory or other bodies where these are relevant to the validity of the application of the results. So this clause is dedicated to for sampling activities. If the lab is doing sampling, then they have to clearly address in their certificate this particular point K. But if the laboratory is only dedicated for calibration or testing, but they have to mention in your quality manual the point K, not applicable to us. So this type of thing, and the statement of the effect that results relate only to the items tested or calibrated sample. The results where the appropriate the unit of measurement. And these clearly things people are writing. There are two types of units. One is will called absolute unit, one is called relative unit. Absolute unit in the SI unit, which is a mandatory requirement of this particular standard. If you're rotating the pressure, report in the Pascal. That is SI unit. And if it is relative, that is the percentage. These two units are allowed, but without any unit, measurement has no value. So be critical, always mention in your certificate the value what you are measuring in the units. It can be relative, it can be absolute. Addition to deviations or exclusions from the method, identifications of the persons authorized the report. So these are very important, and this is not necessary, but for our accreditation bodies, authorized signatory sign is very important. Therefore, we make specially, and there is special provision. We are giving the status of authorized signatory to the persons. So that is very important. So that has to be taken care of. Otherwise, if you taking the like a NPL certificate, they are signing 3 cent, calibrated by, checked by, and then scientist in charge or who is approving the certificate. So that is very important. But some people are putting only 2 signs, calibrated by and authorized by. So it depends to handle the situation. But it is clearly understood which persons are doing the calibration and which person are authorizing the things. Because authorizations things are approved by enable in the special, they are giving the person authorization. This person is responsible for the results and giving the information in the certificate. Clear identification when the results are from external provider. So when the results, some results are, if you are taking from the external providers, that has to be mentioned separately in the certificate, including the statement specifying that report shall not be produced except in full without approval of the laboratory on, and provide assurance that the part of the reports are not taken from its context. This generally happen when they giving some reference to that report in their statement, or they're writing some notes on something that is not allowed by this particular reporting the results. Now there is common requirements for the reports, test, calibration or sampling. The laboratory shall be responsible for all the informations provided in the report except when information was provided by the customer. Data provided by customer shall be clearly identified. In addition to, a disclaimer shall be put on the report when the information is supplied by the customer and affect the validity of the results. So there is a provision in this particular standard. You can put a disclaimer if that information is provided by that laboratory or customer, so we are not responsible for it if we affect the validation of the results. Where the laboratory has not been responsible for the sampling stage, the sample has been provided by the customer, shall state in a report that the results apply for the sample is received. This clause is very important for the sampling exercise. When your lab is dedicated for sampling, then you have to do it. Now specific requirement for the test report, because they especially mention about the specific requirement for test report for calibration and for sampling. They have issued the special instructions, specific requirement for every activity separately for test, for calibration and sampling. In addition to the requirement listed in 7.82, test report shall where necessary for interpretations of the test result include the following: information on specific test conditions such as environmental conditions, where relevant the statement of conformity with requirements of specifications, where applicable the measurement uncertainty presented in the same unit as that of the measurand or then relative to the measurand percentage. It is relevant to the validity of the application of the test results. A customer's instructions so require or the measurement uncertainty affects conformity to a specification limits where appropriate opinion and interpretations. This is 7.8.7, we will discuss later on, and additional information that may required by specific method authorities, customers or groups of the customer. And specific what I discussed in 7.82, when the reporting the results, some conditions are also put by our accreditation body that should become in the report. Maximum points are covered in 7.82 reporting the results, but like a UR number, which is condition given in by our accreditation body, that number has to become on your test report or calibration certificate. Some other conditions also mentioned that as we put the logo conditions that as we put by accreditation body as per their documentation NABL 133. So that has to be followed when you reporting the results. So both the things go together. What you are doing as per the ISOIEC 1025/2017 standard and what the things are condition put by your accreditation body like our NABL in India. So same thing you have to apply it in your reporting the results. Where the laboratory is responsible for the sampling activity, test report shall meet the requirement of listed in 7.8.5 where necessary for the interpretation of the test results. This is the specific requirement for calibration certificate. In addition to the requirement listed in 7.8.2, which we have discussed later and all these things, calibration certificate include the following: the measurement uncertainty of the measurement results presented in the same unit as of the measurement. This practice normally people are not following. They're reporting the result in unit, they're reporting the uncertainty in percentage. But the condition of standard is that unit should be same. If you are reporting the result in percentage, then uncertainty should be reported in the percentage. But many practice I have seen it, they are reporting the results in the tabular form in the unit, but uncertainty they are reporting in the percentage. So that should be done in the same unit. This is a requirement of the standard. And this is meant for calibration. Test report is also there. We are not following so strictly because testing sometimes uncertainty of measurement is difficult. Taking all the components because all the components are the different unit and you have to make in reporting the result in one unit. So therefore relative percentage is more prevalent in the test reports. But calibrations, this practice you have to follow. If you are reporting the results in some units, then uncertainty should be on the same unit. But this is a common practice. People are reporting the results in some unit and then uncertainty in the percentage. According to ISOIEC Guide 99, the measurement result generally expressed and single measuring quantity value include unit of measurement and the measurement uncertainty. This is the way of reporting as per ISOIEC Guide 99. They have put some guidelines how to report the results because normally we give the uncertainty of measurement. So sometimes if you are measuring some value, you have to write a measurement value plus minus uncertainty in bracket. This is the way of presenting the uncertainty of measurement and with the value. I think nobody is reporting the result in that way only. But this is ISO Guide 99 giving the way how to present the report. Suppose you are getting the mass for 100 grams, 100.9 grams, and uncertainty you are getting 0.03 milligrams. Then you write a result like 100.9 plus minus 0.3 mg bracket. This is the way of reporting the result for every parameter. Not this is giving the example of mass, but you have to report the result like that only. So that has to be followed. Therefore, they are specially mentioned different specific criteria for testing, calibration, and sampling. So, first condition is that the conditions environmental under which the calibration where the made have an influence on the measurement results. So this is very important. Actually, you have to mention the actual temperature for calibrations, because sometimes we have to put the corrections from that particular temperature, because normally we have got the habit to write in bracket 23 plus minus 2, 23 plus minus 5, 18 plus minus 5, something like that. Now you have to put a correction from which temperature you will put, 23 or 25. It will make a lot of impact. So if you make a practice to giving actual temperature of calibrations, or you have to add some corrections from that particular temperature, it's easy for us. Don't put in the range, because like in force proving instrument, generally calibrated range is 23, 18 to 28. You have to carry out the calibration 20 plus minus 5. So if it is a metallic material and your instrument is calibrated on 23 degree, if you going outside at that temperature, then its temperature is 25. So 2 degree compensation you have to done in for thermal temperature. So that how will you do it? So they are more specific giving the things. If you can mention the actual temperature in your calibrations field, then if they've applied some correction, you can easily apply it. Otherwise, you have to keep with the starting temperature, you have to apply the correction. Like a range is 23 plus minus 1, then it go for 21 to 25. So now you have to apply the temperature correction, you have to apply it for 23. But that is not very specific. It make a lot of effect on your calibration system. The result before and after the adjustment and repair or available, the result actually if you have to making some adjustment with the instrument, then before adjustment and after adjustment you have to take the results. But normally I have not seen the certificate which are certificates are available before adjustment and after the adjustment. But this is a compulsory conditions. It gives the health of the particular equipment. If it is adjusted or something like that has been done, then we know the health of the equipment for calibration purpose. Where relevant, a statement of conformity with the requirements. This statement of conformity decision rule is very important, and they are more stressing on many points in this particular standard. Where appropriate opinion and interpretations as per 7.8.7, we discussed these are two things are different. Statement of conformity and opinion and interpretations. These are two different things. These giving the things of your views with contacting with the contract with the customer. Then you have to give it in that your test report or calibration certificate. This is a specific requirement for calibration certificates where the laboratory is responsible for the sampling activity, calibrations, certificate shall meet the requirement listed in 7.8.5 where necessary for the interpretation of the calibration results. A calibration certificate or calibration label shall not contain any recommendations on the conditions calibration interval except where this has been agreed with the customer. So this 7.8.43.3 is a really disputable. There are a lot of discussion was going on calibration interval. Sometimes we give it, sometimes we don't give it, sometimes say it is not necessary, sometimes say the requirement of the standard, we will not give it. Next calibration due because we are not very honest. So therefore we are time, may recommend at least you give the suggested date, recommended date for the next calibrations. I'm not telling you give a order you focus submit the instrument for next calibration on this particular date because we are not very honest. If you are working on 1 year caliber and it is fell down, nobody will come again for calibration to that particular lab. He will continue move because validation period is valid for 1 year. Many things are done because we are not honest. So therefore this clause is very important for calibration interval and many documents are available. If you guide yourself with this particular calibration interval, there are many documents are available. First thing is that what your NMI is following. National Metrology Institute, which is NPL in India, is doing it for calibration interval because it is compulsory for every certificate of NMIs. They putting the suggested next date, recommended date for next calibrations. They are putting that particular clause. So first point is that you have to follow NPL guidelines, which is National Meteorological Institute. Every one NMI is for one country. So that is the prime body for deciding the calibration interval. Second thing is that then the appellate document P10. You have to follow P10 document to decide your calibration interval. And their other bodies documents are also available and many documents are available on inter. You can go for NATA document, that is also very good for deciding the calibration interval because calibration interval is distributable, it cannot be lifetime. And this is a general practice in India. If you don't put next date for calibrations or recommended date or suggested date, that person will never turn up. This I have seen practically. And what is the scenario going in India for your technical requirement? At least you guide the customer who has come for your calibration, if you go for this particular calibrations. And when the calibration, next calibration is also recommended in many standards. Like force proving instrument, they require 26 months. So don't cross that limit. Like a UTM hardness tester, 1 year. So that you have to follow in many things standard as guiding, but in many standards they are not recommending any guidelines for the next calibrations because the general policy when we writing this particular standard is that how much you are using, then you have to decide your calibration interval by the customer, not by the calibration agency. This was the concept when we writing this particular clause 7.8.4.3. But it is necessary, please recommend or suggest so that you can guide your customer ki next calibration. It can't be lifetime. Suppose you calibrate one instrument and don't use it and keep in your almirah in good packing condition, but at least environment is always affecting it. So you can't say ki your instrument is for lifetime. We will not do the calibration, we don't use it. After calibration we keep it. So that has to be follow policy, and when they're putting a sticker, so very tricky situation is there. Don't put the next calibration due. Don't put your decision on the customer. Customer has to decide, but for sake of this division, you have to follow particularly about the next calibration date because this point is very distributable. Many points customers say you give me 5 years, and sometimes by your practice, your experience, many things you put it to it should not be more than 1 year. So sometimes we make a policy, like a digital equipment, we have made a policy for 1 year. Like a thermometer, we made a policy of 1 year. So this type of things you have to follow. And I told you which things you can follow with your documentation, but don't put increase the things, because you say our more finance are involved in the calibration cost, calibration fees. That is not the things. It is increasing your the health of the equipment. Drift, other things, bias. You also know increasing the health of your things, and many things can be taken care of your uncertainty of measurement if you are following the regular calibration interval. Therefore, yesterday I discussed about the calibration program. That is an important point for calibration point of view. But 7.8.4.3, you could not be agree with the customers, because customer wants always the increased calibration interval. But there is some limit for it, and you are also be reasonable for that thing. So, like vernier caliper, if somebody like in railways, they are using particular equipment daily, 3 times, 4 times. So frequency has to be reduced. Like railways, they are using many equipments in aviation industry are using frequently, 6 times, 7 times, 8 times. So normal lab culture and that particular aviation industry, the same calibration interval can't be hold same. But in our India, we are holding the same. We are not very honest about our calibration interval. If something goes wrong with the equipment, since certificate is issued for 2 years, they never come back for the calibration. So this is, I am telling you very frankly, this is very point disputable, and this is many times were discussed on many platforms, and our action body has put some documents also regarding this. But this, if you are very honest, you can always decide your calibration interval on the use. And these standards spirit is that if you are using the instrument frequently, reduce your calibration interval. Don't keep with the calibration agency. So that is most important point for calibration interval. And when you're putting a sticker, never put your decision on the your customer. Next calibration DO. If you want more diplomatically, you can put suggested date or recommended date. Because in Indian condition, Indian scenario, you have to guide the customer when he has to come again for the calibration or test. So that is the important point of this particular reporting the results. This is for sampling, because sampling, how you are doing the sampling, what is the date when you do the sampling, and people understand the sampling is a arbitrary exercise. Sampling first time was added this particular standard, and sampling is very technical, very scientific. How to make a sampling? So these are the specific samples you have to add in the sampling when you're doing the sampling certificate. So reporting the statement of conformity. This is 7.8.6. So when you this clause also discuss at the time of making a contract with the customer. So that is very important. So you will be clearly understood the statement of conformity. If you are giving some class, some percentage with the reporting results, that is called a statement of conformity. This instrument belongs to class 1. So this is a statement of conformity. But don't confuse with the statement of conformity and the decision rule. Because decision rule, the uncertainty is also covered in the decision rule, which is we call a fail or pass. But statement of conformity, this instrument is confirmed to refer to this particular standard, and this is found up to this accuracy. So this is called a statement of conformity. So many statements are going on: statement of conformity, decision rule without uncertainty, decision rule with uncertainty, guard bands. Many things are going on this thing. This is a wide subject about decision rule, and I think today we have got a full series of that, full lectures on the decision rule. So that has to be understood with context to this particular clause. And in service request form, when you are making a contract with the customer, it should be clear whether the customer wants decision rule in the certificate or not. Because 99% customer doesn't want in India the statement of conformity or decision rule. They say that we got a failure, but it is a clear indication of your results, clear analysis of your results with the things are available with the manufacturers with the standard. So when you're making this thing in your service request form, you should be clear with the customer what he wants in the statement of conformity or decision rule. Both these things are different. First you understand like that. When a statement of conformity to a specification or standard is provided, the laboratory shall document the decision rule employed, taking into account the level of risk such as false accept or false correct and statistically assumption associated with the decision rule employed and apply the decision rule. So, so this is the only things. Risk is on a plot. It is a very clear mentality that if we send your instrument or your calibration result are rejected due to a statement of conformity or decision rule, then customer will never come back. So this is your risk for your business. So risk factor, people understand risk was clearly understood. If you want to more detail about the risk, you have to read ISO 31000 standard. There is a complete ISO standard about the risk. But risk factor is very important, clearly mentioned, clearly understood, because people in our India generally ignoring the risk factor. But risk, without risk, you could not grow in your business. So risk factor clear in your mind. I'm not discussing about the risk factor, but risk is very widespread factor which help for your business. Not go to your business to negative growth. So that is the important point of it. But when decision rule is says, when you are giving a decision rule, false or pass or fail or it is very near to that things or fail or pass, it will clearly risk to your business. So therefore the risk factor is involved in this particular clause 7.8.6.1. There is a decision rule is prescribed by the customer regulations or normative documents. Further consideration of the level of risk is not necessary. So when it is already inbuilt, like in mass calibration, decision is all inbuilt itself. In many factors, many certificates, many parameters, decision rule is inbuilt what you are reporting actually, and statement of conformity actually is coming in that. That has also be understood with the reference to the particular parameter. So this is a statement of conformity. The laboratory shall report on the statement of conformity such that the statement clearly identified to which results the statement conformity applies, which specifications, standards, or parts thereof are met or are not met. The decision rule applied unless in its inherent in the requested specifications or standard. For further nomination, you can read about this decision rule in Guide 98 Part 4. So this is the opinion interpretation. Sometimes we have to say yes, we are meeting with this particular standard or not. We have to give opinion interpretation. But the persons who is confirming the opinion interpretation should be qualified person. At least he should be in authority in that. Like in particular lab, what I told yesterday, organizational structure, some calibration engineers putting opinion interpretation. This is not allowed. He should have that person who is putting the opinion interpretations. He should have in-depth knowledge about this particular parameter. That is the requirement of this particular clause. Standard is saying you can report opinion interpretations about the results, about the method, what the customer wants, but It should be given by opinion interpretation should by the some persons who has shown the in-depth knowledge, lot of experience about regarding that particular parameter or particular results we are operating. When opinion interpretations are expressed, the laboratory shall ensure that only personnel authorized for the expression of opinion and interpretations release the respective statement. The laboratory shall document the basis upon which the opinion interpretations have been made. It is important to distinguish the opinion and interpretation from statement of inspections and product certification as intended to ISOIEC 17020, ISOIEC 1065. So inspection standard is ISOIEC 17020, and for product there is a different standard ISO 675. So this should be different from that your opinion and interpretation. The opinion interpretations expressed in report shall be based on the results obtained from the tested or calibrated items and shall be clearly identified as such. When opinion and interpretations are correctly communicated by the dialogue with the customer, a record of the dialogue shall be retained. So amendment of the reports. So this case, when something goes typographical mistake or some data or some mistake has been done in the results, so that has to be giving the amendment of the report. And when you have to give amendment, there are many ways of giving the amendment of reports. So you can write when your certificate number is amend number so and so or report new number with and in lieu of that you give the old reference report which has to be amended. So there are giving the procedure when an issued report needs to be changed, amendment or reissued or any change of the information sheet shall be clearly identified where appropriate. The reason for the change include in the report. So when why you are changing it, you put in a remarks column and you put why we are changing the report. It should be verified on every report has to be amended when you issue the new reports. An amendment to a report after the issue shall be made only in the form of further document or data transfer which include the statement, a amendment to the report, serial number for the otherwise identified or equivalent form of wording. Such amendment shall meet all the requirements of this document. So when any amendment of the reports, whether it is a small mistake, big mistake, amendment of the report has to be issued with the guidelines issued by this particular document or standard. When it is necessary to issue a complete new report, this shall be uniquely identified and shall contain a reference to the original report. But there are some policy of the lab for duplicate report. So that has to be separately mentioned in this your quality manual or document manual. Because duplicate of the report is separate from the amendment of the report. You have sent the report by courier, it is lost. So you are issuing the duplicate report. So that has to be mentioned because that is not clearly mentioned in this particular standard amendment of the report, but duplicate of report you can mention. We can issue the duplicate report on checking the things or the statement that something is lost in the courier or post or something like that. So duplicate of the report you have to give in this particular clause. So now we come to the next clause 7.9 complaint. So complaint is one of the important point, but first you have to verify it is a complaint or it is something. So like you put the wrong number on your instrument number on your report when you issue the report. So you have to change the things and you issue the report that will come in the amendment of the report. It is not a complaint. But people are taking a very thin line with the amendment of the report or the complaints. Complaint means really any non-conforming verb or technically clearly understood, or there are some pattern in the reports. Some reports go for increasing order, some go for decreasing order. Same pattern has to be followed, and if in between some reports are increasing, then it is going on decreasing, then it is going to increasing, so something wrong with the report. Or once you issue the report and something that your traceability has gone, so that sometimes customer, when you issue the traceability certificate to the particular lab, so he says your instrument is not traceable. So this is called like a complaint. First you understand what you mean by complaint. Complaint in general way it can be understand which is not meeting with the expectation of the customer. It can be document wise, it can be your certificate wise, output wise, something like the instrument, your method, you are doing the things, you have to do the result. Standard says you have to done the result 10 times, you have done the result 5 times. So at this time of complaint, first you have verified whether it is a complaint or not. A complaint understand which is not fulfilling the customer need. The laboratory shall have a document process for to receive, evaluate, and make decision on complaints. So this is the things. You hear the word you use, document. You have to make a document process. So you have to have one document which is giving the flow chart. Complaint will be received at your customer care. Customer care will forward to technical manager. Technical manager will discuss with quality manager, and both will discuss with the head of the laboratory or the CEO of the laboratory, and again come back to the quality manager or technical manager. Technical manager will discuss with quality that calibration engineer, and then it will be reviewed by the external body, and then it will be communicated to the customer. The result of that particular complaint, how they resolved it, or there is a complaint or not, or something wrong with your system, that has to be governed the thing. This is the process. So you have to document in a flow chart the process how to tackle the complaints received from the customer. So that is the first point is that you make a sub document process. How to tackle the complaints, how to receive the complaints. That is the first point of this particular complaint. And these complaints previously in the old standard only that 2.5 lines, but now they are giving devoted 2 pages or about the complaints. They are more worried about this particular clause. A description of the handling process for complaints shall be available to any interested party on request. Upon the receipt of the complaints, the laboratory shall confirm whether the complaint relates to laboratory activities or and it is responsible for and so and shall with it. The laboratory shall be responsible for all decisions at all levels of the handling process for complaints. The process for handling complaints shall include at least the following elements and methods: descriptions of the process for receiving the validating or investigating the complaints and deciding what actions are to be taken in the responsible response to it, the tackling and according to complaints, including actions undertaken to resolve them and ensuring the appropriate actions is taken. The laboratory receiving the complaint shall be responsible for gathering and verifying necessary information to validate the complaints. Whenever possible, the laboratory shall acknowledge receipt of the complaints and provide the complainant with the progress report and the outcome. The outcome to be communicated to the complainant shall be made by or reviewing and approved individual is not involved in the original laboratory activities in questions. This can be performed by the external person. This is the only change come in the complaint clause with the previous standard. your complaint has to be reviewed by the external body. Means the person who has not engaged with the laboratory activities. It can be your marketing persons, which is not involved day-to-day daily practice of the laboratories. It can be external persons who is not taking care of their laboratory activity. It should be reviewed with it, and this has to be then after reviewing by that third party, it has to be communicated to the customer. Whenever possible, the laboratory shall give formal notice to the end of the complaint handling to the complainant. When the customer makes complaint, then what are the results of coming of that complaint that has to be communicated to the customer who made a complaint. I think I complete all the clauses of this particular both the clauses. So thank you very much.
Thank you very much, sir, for your kind words and clearly explaining all these clauses. Really, you have explained the things in a very well manner. Even I think I could understand very well.
So today I complete all the things on time.
Sir, thank you very much. You have done it within time very much. Thank you very much. So my request is, if you want to continue with the class 6.5, you can continue.
Right. Okay. Thank you so much.
Please, 6.5. Sir, can you continue with the class 6.5? Should I share the screen? Should I share the screen for class 6.5? Or you are sharing?
6.5.
Yes, sir. Yes, sir.
6.5 I have to cover.
Please, sir. You cover.
Eh?
Yes, sir. You please cover it.
You will cover it.
You do it, sir. No, sir. You do it now.
I have to make it. I have to find out.
Okay.
Otherwise, I just explain in 5 or 10 words. That is a metrological traceability.
Yes, sir.
How you are maintaining your metrological traceability, that is important. And if you go, it is in the form of pyramid. It is started from BIPM, then your NMI, then your working labs, primary working labs, then come like that. This is a phenomenon of metrological traceability. And it should be the SI unit. And they also mention if you are any unit you are not mentioning in SI unit, that has to be done. You have to give the way why you are not maintaining that particular SI in SI units. So this is a way of metrological traceability, and they give special annexure in this particular standard. Annexure A, which is giving only about the metrological traceability, and this word metallurgical is used first time in this particular standard. Otherwise, if you read all standards, old standards, they are talking about the traceability only. Now they are very much clear about how to maintain the metrological traceability. So when you are making any parameter, you are maintaining the metrological traceability, so at least you have got the chart with you. How you are calibrating your equipment, and where you calibrated your equipment, from which lab, and their equipment are calibrated from where this. So you have to make some metrological traceability charts for every parameter. And when you are not doing anything in SI units, you have to clearly identify why you are not doing it. Like in pressure, if you are doing in kg per centimeter square or bar, that is not allowed by the standard. So you have to give specific region or specific evidence about this particular clause. So metrological traceability is one of the important factor which you have to forward, and 6.5 special clause has been mentioned about this metrological traceability. You have to maintain, but we all writing in our certificates, we are all traceable to national standards, which is not likely. You are traceable to particular lab from where your instrument is calibrated. So this is every certificate you've seen in India are all traceable to NPL, but NPL is not doing so much work. I am very clear about it. If I write, I say my standard is traceable to this particular lab. So be practical when reporting about metrological traceability. So 6.5 clause only dedicated about metrological traceability.
Okay, thank you very much, sir.
Make that things of like a file of to present to different clauses, but this is a core of that particular clause of 6.5.
Sir, there is one question from the participants. They are asking, does frequency of...
Your voice is not coming clear.
My voice is not clear?
No, not clear.
Now it is clear?
Yeah, it is clear now.
Okay. Sir, there is one question. Does
Hmm.
clause 7.4 also
Hmm.
includes CRM, SRM, RMP, etc.? And when we
Uh-huh.
talk about 7.4, it speaks about the handling of test or calibration items. So as
Hmm.
far as from the subject is concerned, from the clause is concerned, it
Hmm.
only speaks about the handling of test or calibration items, but it does not speak about the CRM, SRM, or the standards. Basically, we could say.
Hmm.
So we can reply to this question that this clause 7.4 is only applicable for the test or calibration methods. Am I right, sir?
Right, right.
Thank you, sir. So next question is, what are the three components required in
मेरी
a
आवाज यार बहुत डिस्टर्ब हो रही है यार, क्या क्या चक्कर है यार?
सर
क्लियर समझ में नहीं आ
आपके
रहा
बैकग्राउंड में आवाज आ रहा है सर आपके
है।
बैकग्राउंड में आवाज है
क्या जी?
आपके बैकग्राउंड में काफी आवाज है
हाँ, बैकग्राउंड में वो मकान बन रहा है ना साथ में।
ओ
अब ठीक आ
इसीलिए
रही है, अब ठीक आ रही है, अब ठीक आ रही है।
ओके
मैं भी दरवाजा
सर
बंद करके आता हूँ एक मिनट।
हाँ वही वही बैकग्राउंड में काफी आवाज थी
हम्म।
Yes, sir. Now it is okay. Thank you, sir. Thank you very much. Since 1 hour, we were trying to, we were just concentrating upon your words to
हम्म।
just pick it up of you because
हाँ।
there was a lot of disturbance from the behind. Sir, there's one another question. What are the three components required in a traceability plan?
हम्म।
Sir, now Butter Singh ji is also with us. And yes, sir, what are the three components required in a traceability plan?
हम्म।
Next question is,
Traceability plans, I just give the reply.
please, sir, please.
Traceability plans means from where you have to submit the instrument for calibrations, and what is the your basically accuracy and TR ratio. So that is the 3 points which is the basis for the traceability. If you are required a 0.1%, so at least you go to the lab for traceability 0.01%, which has got the accuracy, because accuracy should be better than 1:4 ratio, but if it is 1:10 ratio, then it is better. So these three components, what is for you going for traceability, reputed lab, what is CMC should be better than TR ratio 1:4, or if it is 1:10, that is a better. So this you making a traceability plan where you go to see. And third is, what are the instruments they have got where you going for the traceability. So you have to make a traceability chain in the pyramid shape, highest to lower. आशुतोष जवाब हो गया?
Thank you very much, sir. Thank you very much. It is a very good reply. So my request is, if you can kindly reply in the WhatsApp or in this chat box, it will go to all. And I think they will be, because these are the three components and everybody will understand. My request is kindly WhatsApp it to me so that I will put it in the chat box.
Right.
Thank you very much, sir. Sir, the next question is, अगर कोई कंपनी ओनली मार्केटिंग ही करती है तो
हाँ।
उसे लीगल मेट्रोलॉजी का लाइसेंस लेना जरूरी है, और कोई कंपनी ट्रेडिंग कंपनी है तो क्या उसे भी लीगल मेट्रोलॉजी का लाइसेंस लेना जरूरी है? यस, एज पर द लीगल मेट्रोलॉजी एक्ट सेक्शन 23 वेरी क्लियरली स्पीक्स about the manufacturers and the dealers and the repairers, that whenever you are doing any manufacturing or dealing of the weights and measures or doing any type of repairing, you need a license from the state government. Thank you. So the next question is, can you explain non-numerical measurements in relation to uncertainties?
Again, repeat the question.
Sir, sir, उनका क्वेश्चन है, can you explain non-numerical measurements in relation to uncertainties?
Non-numericals.
जी.
Uncertainty is always come in the numerical forms.
Can you explain non-numerical measurements in relation to uncertainties?
नहीं, but question is very not was clear. What he wants for non-numericals.
सर वो क्या कहना चाह रहे हैं कि if they are doing a measurement in which in place of getting the results in the form of a number, they are getting in terms of non-numerical. That means qualitative, we can say, in relation to uncertainties. Whether we can find the uncertainties in this case?
No, if their relation was sampling or something like, because non-numerical will never play a part in uncertainty. Uncertainty comes with some values. Uncertainty of measurement. Measurement always comes in some values.
Yes, sir.
And without measurement, uncertainty will never come.
Okay, sir. Okay, thank you very much, sir. Thank you. Sir, the next question is, recalibration is required if master equipment shifted to one laboratory to another internally, which are located at different location. So basically he just want to say within the premises or within at one place, if you are changing the location of a master equipment from one room to the another room, only the recalibration is required. Is it okay, sir?
No, if you shift the instrument from one corner to second corner, you have to require a recalibration. This is a compulsory condition of the standard.
So we have to do
for everything, any change to small movement of that when his instrument is calibrated, instrument is again to have to go for recalibration.
So the same thing he's saying, sir, from recalibration, only recalibration is required if master instrument shifted to one laboratory to another internally, which are located at different locations.
So recalibration is required.
Recalibration is required. It is okay.
Okay.
So next question is it a mandate for laboratories to include evaluation of uncertainties in statement of compliance?
There is actually in this particular standard, there is no word for statement of compliance. There is a statement of conformity and the decision rule. These are things. Statement of compliance is no mention in the standard, and it is a requirement of the customer.
Okay.
Laboratory has not give the compulsory, they have to give the statement of conformity. It is a requirement of the customer, and what customer wants, from which standard, and what is his meaning. Without uncertainty, without the uncertainty, but it is the statement of conformity is the prerogative of the customer, because customer is the main part who can play like that.
Okay. Sir, the next question is it required to specify how a client conducts sampling? Is it required to specify how a client conducts sampling?
Yes, compulsory.
So that means if the sampling is being done by the client in place of the laboratory, that has to be mentioned in the sampling plan.
Sampling plan, as soon as you start the process, everything has to be recorded. Okay. Sampling is very important because it depends on the time.
Okay, sir. Okay. Sir, next question is, what does 17025/2017 require as considerations in metrological traceability to the SI? Once again, I'm repeating, sir. What does 17025/2017 require as considerations? What will be the requirement? What will be the considerations of the standard?
Before answering this question, I want to refer 2-3 documents. You can refer to it. Once the annexure of 17025 standard about metallurgical traceability. They give one page annexure for metallurgical traceability. Then you have to refer NABL 143.
Okay.
So these two standards giving the clear picture about how to maintain the metallurgical traceability. And I also told at least you have to maintain the TR ratio for maintaining the metallurgical steps. Means your requirement is 1%, so at least you go to that traceability to 10 times better. It will maintain your unbroken chain of traceability. This is per the definition of traceability.
Okay, sir. Okay. Sir, the next question is, Beauty refractometer is used, which is maintained at 40 degrees Celsius. If one has to shift a method to a digital refractometer using manufacturer's process, does the data need to be proved digital meters compatibility?
दोबारा रिपीट कर, दोबारा तेरी आवाज वैसे ही ब्रोक कर रही है वैसे।
ओके सर, ये जो विट्रो रेफ्रेक्टोमीटर होता है, इट इज
हाँ
यूज्ड एट 40 डिग्री सेल्सियस. If one has to shift method to a digital refractometer using manufacturer's process, does the data needs to prove digital meters compatibility?
यस, कंपैटिबिलिटी यू हैव टू प्रूव इट।
Okay, you have to prove it. Okay, thank you, sir. तुमसे तो मोबाइल ना बताना था, देखो रौनक 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 बेटा एक मिनट बोलना है तुमको, इधर वहां क्यों बैठो आप, वहां कुछ नहीं बोलता मेरे को, सब बात करो, बंद कराओ। वो क्या करें, फोन जा रहा है। Sir, the next question is, sir, the laboratory is following NABL, but in 2022 they have found that the auditors who are there do not follow the NABL 129. Sir, is it necessary to follow 129?
It is not necessary.
Okay. Okay, so guideline, not necessary. Okay. Sir,
I am very specific about it because this is only guidelines. This is not a standard. So it is a guideline. It is giving the standard for making the uniformity of the auditors.
okay.
But if you have got the relevant standard with you and you are following every policy of it, then enable 129 is not required. But clearly you have to mention, don't follow the New Zealand standard, South Africa standard to say yes, we are following some standard. It should be ISO or ASTM standard, international level proven standard, not an accreditation body standards. So enable 129 is a guidelines. It is your will you are follow or not. But what you are following as per 17225, it should be on the written international standard which you are follow. It is not necessary.
Okay, sir. Sir, especially in cube mold, पाया है कि कुछ ऑडिटर वर्नियर को एज पर मास्टर एक्सेप्ट करके स्कोप फाइनल करते हैं, बट कुछ ऑडिटर वर्नियर को एज पर मास्टर एक्सेप्ट नहीं करते।
तो क्यों नहीं करते? ये मेन रीजन ये है कि क्यों नहीं करते, क्योंकि उसमें इतनी एक्यूरेसी रिक्वायरमेंट ही नहीं है। स्टेटमेंट वर्नियर कैलिपर से हो सकता है आराम से।
ओके, तो दैट मींस
ऑडिटर की अपनी बिल है।
ओके, दैट मींस
उसमें जो क्यूबिक मोल्ड है उसमें बहुत ज्यादा 3 से 4% की एक्यूरेसी रिक्वायर्ड है, तो वर्नियर कैलिपर भी चलता है उसके अंदर, ऐसा कुछ नहीं है।
ओके,
आई एम नॉट द एक्सपर्ट ऑफ द दिस डायमेंशनल, बट फ्रॉम माय एक्सपीरियंस आई एम टेलिंग दिस थिंग्स।
ओके सर, ओके सर, थैंक यू वेरी मच सर। वर्नियर कैलिपर कैन बी यूज्ड फॉर दिस पर्पस। what it is observed that whenever the laboratories are declaring or giving these uncertainties, they, in place of giving the uncertainty of a particular weight, they used to mention the uncertainty of the uncertainty of the E1 class or E2 class or ever F2 class. So they mention the maximum uncertainty which is mentioned in the OML 111 R111 in place of this. So is it okay, sir?
दोबारा से रिपीट कर, मुझे जो किसकी बात कर रहे हैं
सर मुझे क्या लग रहा है, when you will see in the calibration certificates, what the laboratory used to do, let's say we are doing the calibration of F1 class weight.
Right.
In F1 class weight, we used to find how much is the error or how much is the value we obtained, mass value we obtained, and in the uncertainty column, we used to mention the uncertainty given in OML R111 inside that column of that F1 class.
नहीं, but where is written in uncertainty in the particular column of the table? They are not written like that. Uncertainty should be given in the first page, is given the standard. It should be the 1/3 of the MP.
Okay.
They are not written in the table. This is uncertainty. Next table is uncertainty. That will be assumed. This is not written on the table. So you have to calculate the uncertainty and what is the MP of that particular weight. It should be come in that. It should be equal or less than that of MP.
So that means, sir, we are not giving the uncertainty of that particular weight which has been calibrated. We are just giving the uncertainty which is actually required as per the standard.
Yes. We do not have to follow the uncertainty per the table, which is given the OML R111.
Okay.
We have to calculate the actual uncertainty and that has to be reported, and it should become within the 1/3 of the MP.
Okay. Sir, we have some other questions. Sir, is it necessary to do measurement uncertainty for in-house calculation check, in-house calibration check or for intermediate check? For example, for pH meter, the laboratory does calibration check before use, and for this measurement uncertainty required.
He is talking about the intermediate check.
Yes, sir. Yes, sir.
Intermediate check, no uncertainty of measurement is required. That is only the stabilization of that particular equipment or measurement. So no uncertainty of measurement required. But if he relates that uncertainty of measurement with their CMC and other, then they have to report. Otherwise, if you take the measurement value and how you stabilize it, it is okay.
Okay, very good. Thank you, sir. Thank you very much. So it is very clear, that very good clarity that for measurement during this intermediate check or retention test or any other test during the laboratory of the checking its accuracy, there is no need for measurement.
We have to refer the equipment clause which we have yesterday we have discussed.
Yes,
6.12, 6.4 and 6.5. We clearly understood what the meaning of that.
Thank you, sir.
There is a separate clause for validity of the results, PT or ILC and other things.
Okay, sir. Thank you very much, sir. Sir, next question is, uncertainty is also used for sample passed by doing plus or minus value or by adding.
What? दोबारा वो repeat कर.
Sir, I think question is not complete. They are saying reference standard is very expensive. So can we create and use in-house working standard against reference standard?
Yes, because you have to make a chart of that thing. Reference equipment, your working standard equipment, your secondary equipment, like in weights in legal metrology. Reference weights is almost not regularly used. Only the working standard is used. Therefore, you can do like that. If you are working I give you example of prototype. Prototype is costing 3 crores. We are not using it daily practice. That is our reference standard in marks. So we are using the working standard. Same thing, your policy you have to adopt.
Yes, sir. Yes, sir. Very good. Sir, next question is, can we perform the ILC with our sister laboratory having same name of organizations but different locations and having better CMC? Sir, I think it's a very good point. Basically, let's say we are the top management is the same, However, under the top management, two different heads are holding two
No,
different
no, this
locations
standard,
and two
no,
different.
this standard is allowed these things. You
This
can do it.
standard allows.
This
You
is
can do it.
standard
Very
now.
good.
The terminology is called intra-laboratory.
Yes, sir.
Previously it was inter-laboratory. Now it is
Yes.
the word they have used intra-laboratory. So you like a big organizations, they have got 2, 3 sister labs, they can do themselves.
Okay.
This
But
is
sir,
allowed to standard.
apart from intra, they have to do inter also.
Yes, they can also do it.
Okay.
If
So
you
you
got a
will
better
consider it.
CMC in their lab, they can do it.
Yes. Sir, actually what they are asking, the CMC is better, so whether they can use the another sister laboratory because
Hmm.
the heads are different, the board is different, management is different in the laboratory level, at the laboratory level, like we say in our case, suppose we are the government bodies, we have different at different locations, we have the laboratories. I'm sitting at Ahmedabad, my
Hmm.
another laboratory is Bhubaneswar and Bangalore
Okay.
and
Right,
Faridabad.
right.
So when we can say, because the management is entirely different, I do not have any
No,
contact
no.
with the Bangalore.
This standard is saying कि you can do it, whether your management is same or different. He's not saying
But it
anything
will
that.
be,
If you got in one compound, you got a 4 laboratories, like RSL got a 5 different centers, so they can do themselves. Depend on the CMC. You don't require any special laboratory. You have to go for your ILC or PT. You can do
okay,
themselves. This standard
okay.
allows you.
Okay,
But
thank you very much, sir. Where it is
in
mentioned?
this case, you have to write a letter to your accreditation body. If
Okay,
we are following this practice as per the standard, please allow us.
okay. Sir, my question is why to go to the accreditation body for getting the permission? Where it is mentioned in the standard that you will take a permission and then only you will do for IL, you
No,
will go for ILC.
but same time they have not written. I told you yesterday, na example they say कि one body can do the laboratory, but enable never allows. So you can operate the one persons. I got
Okay,
example. I go for audit for one particular laboratory. There are only two persons. One is the sleeping partner overall, and one person is 55 years old, and he is doing the calibrations. These two persons are doing the calibration lab, and when I go for audit, I say yes, they are very good persons, and we should award them. Then NABS says we could not go for it. I have to fight that particular case for 1 year.
okay, then,
When I go for audit, why I have checked everything, why they are not giving it? So this is the only thing. Permission is not required, but the structures like that, accreditation body is controlling everything for you, and for your business of point of view, you're taking a whole risk, and somebody says no. So risk factors, risks and opportunities. Also, you are discussing today evening. That is the important point for it. But
okay,
permission is not required. If you are following the
permission.
ISO 102 standard in total, there is no permission is required. But this is as made in our habit कि we have to go for permission. Even any amendment of the certificate, you are required a permission of NABL.
Yes,
So
which is
it
not
can't
required
be like
actually.
that because many things do not require the permissions. For ILC on PT, you are required a permission from NABL. If I am doing some ILC for making, why should I require a permission from NABL?
Okay,
Without
very
NABL
good.
permission, I could not proceed for ILC.
So, sir, you have a vast experience of even peer assessment, international assessments. What are the other bodies are doing? How they are handling these type of small petty problems? Basically, we have to concentrate on the
They are
calibration
very
part.
quick. There is no paperwork involved. They bring their artifact in their pocket. They give to the laboratory. Even the assessor doesn't know about their values. Laboratory doesn't know the values. They simply take the values and he take the value and submit to the accreditation body. So this is a fair examples, and they complete the exercise within 1 week. Everything you got the
Okay,
results of everything, and about your doubts, you can clear with the auditor on the spot itself. So many
okay,
things we are lag behind about our accreditation system. We are not very clear because many things our policies are not clear. We are generally
yes.
following the policies giving on the world scenario. Many therefore yesterday before I am talking I am told you what are the things written in the standard that is not written in the thinking of the Indian scenario. It is on the world scenario. Our Indian conditions are very different from world scenario. So many things are different because when you go for international audits, many things are on the clear. Guidelines are clear. Which instrument I have to see. Now in India, if I go for audit, I have to see everything from first to 25 equipments in one day. 2 days I have to complete the report. This is not like that. They give the things clear indication. You have to see 3 equipments and that they make the report. And their reports
Yes.
are online. All person in
Okay.
accreditation board is seeing what is going on in the audit. So this is
Okay.
very much clear because once the audit is clear, now between the matter
Okay.
is between NABL and that particular lab. Audit is gone out from
Okay.
it. Auditor. It should not happen in
Okay.
our accreditation bodies system. So this is totally different. System total scenario is totally different.
Okay. Well, if the laboratory is doing the PT proficiency testing, I think there is no need to go for ILC, or they have to do ILC also.
Yes, because in validity results both are mentioned separately. First thing is
Okay.
that, and there are two documents of NABL 163 and 164. 163 for PT program or NABL 164 for ILC. But NABL make some policy if you participate in PT program, then you don't have to participate in ILC. But it is not a uniform. It depends. It is a matter man dependent. Sometimes you say why you are not participating in ILC. But both the things are different as per the standard.
Sir, thank you very much for your explanation and clearly answering the questions. Sir, we will be again having this panelist questions session at 3:45 today. And I think that we will be having about half an hour, maybe even more than that, because we have to make the things clear to all the participants. And sir, what we will do, my request, my submission to you, sir, and after these, all these questions we will take, and in our government department in legal methodology, what we used to do, we just prepare our FAQs, frequently asked questions, and we just used to publish it on our website. In the same
Right.
way, most important questions which are asked regularly by the participants and are very important for the laboratories, we
Hmm.
can take some questions and we can just prepare their answers so that we can put it on either on our website, and we'll also request to, and we'll send it to NABL to put it their website and just get it countersigned or get it confirmed, just accept it that it is correct, so that we can also give it to all participants, and it will be very helpful for the laboratory, because we have to develop the standards in the country. This is the capacity building of the country which we have to continue, sir. Thank you
Right,
very
right.
much, sir, for
Right, thank
for
you.
your for your help, sir, and we will continue to take your help. I understand that, sir, we are not doing anything for anybody, but still we are taking your help. This is, you are basically still for natural cause, with a good cause of the country to develop the capacity building. Thank you very much, sir.
Right, right.
Thank you.
Thank you.
And sir, my request is you please come at 3:45 or 3:30 so that we
Oh,
can
I
again
will
have a
try my
further.
best. I will try my best, Chad.
Thank you very much, sir.
Okay.
Thank you. So
Okay.
kind of you,
Thanks.
sir. Thank you very much. Thank you. So this
Thank you.
he was Professor Anil Kumar, sir, who has helped us in understanding a lot of things, and question answer session we'll do later on. Now, actually, we were having our as per our plan to go with Sangeeta Negi madam, but I think there's some problem in her connection, and connectivity is some problem. So we will take her at 2 o'clock. Right now, we are going to start with Mr. Battal Singh, who will be explaining the clauses 8.3, 8.4, 8.6, and 8.7. Mr. Battal Singh is also having very good large experience of National Accreditation Board of Testing and Calibration Laboratories. He has a lot of experience in doing the testing and calibration with his own hands. So he's a basically person for the laboratories. If they want to ask anything, they can ask. Battal Singh, please kindly start. But, Atul ji, kindly allow Battal Singh ji to share, or otherwise I will share.
Doing.
Battal ji,
6.5 थोड़ा सा
अतुल जी, इनको जरा दे दीजिए स्क्रीन, बटल जी को
जी सर दे रहा हूँ
शेयर करने का प्लीज.
Permission granted, sir.
Thank you very much. Even it is with me. संतोष जी, अभी शेयर का मेरे पास ही है. He is not able to share.
आप सेव रखो आप वहाँ से बढ़ाते रहना 6.5 खोलो तो अनिल कुमार सर ही है क्लोज वाइज बता देंगे थोड़ा सा हाँ नहीं 6.5।
ये वाला है ना?
अरे ये नहीं है सर, उसमें जाओ ना जो उसमें था, क्लॉज 6 था ना, प्रोसेस रिक्वायरमेंट में 6.5 कर देता
नहीं, पटल जी, you have to speak 8.3 clause.
6.5 रहेगा। ठीक है, 6.5।
Wait once again.
क्या हुआ?
जी संतोष जी।
हेलो, यस सर।
हाँ
ये कैसे हटेगा यहाँ से?
सर ये अभी संगीता मैडम ने भी ज्वाइन कर लिया है और बच्चन
ओके। लेकिन मुझे लगता है संगीता जी का अभी वो स्क्रीन शेयर होगा, बिकॉज शी हैज टू शेयर द स्क्रीन ना। लेकिन सच भी वो, और ये बटन का भी पूरा वैसे आ रहा है जैसे कि आ रहा था मॉर्निंग में।
Should I start?
आपने माइक ऑन किया, आपने माइक ऑन किया।
आपका ही है, मेरा नहीं है। आपका ही है, मेरा नहीं है। मेरा कैसे स्टार्ट करूं? स्टार्ट करूं?
और आपको ऑन नहीं है ना?
ऑन है ना, दिखने ना आ तो रहा है इधर मेरे सामने, तो रहा है।
ऑन यहाँ नहीं आ रहा, इट इज नॉट शेयर। अगेन ट्राई टू, इसको बंद करें बस।
वो बनना होना चाहिए था, कहीं है नहीं।
रिकॉर्डिंग हो रही सर ना? ठीक है सर, ठीक है।
प्लीज स्टार्ट।
Okay, thank you very much, sir. Now we will discuss control of management system documents. Basically, whenever we talk about option A, it means hello. Basically, whenever we talk about option A, it means that laboratory has to follow 8.2 to 8.9. And when we talk about option B, it means that laboratory is accredited, is certified as per ISO 9001, and they don't require to follow 8.2 to 8.9 as per 17025 because they are already followed by them in ISO 9001. So now we will discuss about the control of management system documents. As per 8.3.1, the laboratory shall control the documents, internal and external, that relate to fulfillment of this international standard. The meaning of this is basically the control of document is requirement of this particular standard, and there are two types of documents which can be considered as the internal origin document and external origin document. When we discuss about the internal documents, so there is a hierarchy of the document, and that hierarchy of the document is basically quality management, quality manual, oblique management system document, then quality procedures. There are 8 procedures, and one process. Process is in 7.9.1, which is basically complaint. So this particular standard speak about the process 7.9.1. Why this is written process? Process is written because of it is the language of Casco committee. That's why it is written here. Otherwise, it is also a procedure. After that, there are SOPs, standard operating procedure, which are written on the basis of some document, on the basis of some report, or on the basis of some international or national standard to perform the testing and calibration. Then there are forms and format, because if you see there are many forms and format required to maintain the system as per 17.25. So these are the documents which are of internal origin. Then what are the document of the external origin? The document of the external origin can be the specifications provided by the manufacturer, then manufacturer instruction for a particular instrument, calibration table. Calibration table means, for example, you are performing calibration of thermal and you are using thermocouple. To read the temperature of that particular thermocouple, you need to have a temperature, you need to have an indicator which will convert millivolt into the temperature. Then various charts, textbooks, posters, notices. Notices means if there is any notice given by the government of India for performing any kind of particular calibration or testing. Then some memorandums, drawings. Drawings can be internal or can be external also. Plan can be internal only. So there are two kind of documents, internal document and external document. And these can be through various media. They can be in the hard copy, they can be in the digital form. So we have seen there are two types of documents. Now these documents needs to be controlled. Eight point 3.2. The laboratory shall ensure that documents are approved for advocacy prior to issue by authorized personnel. What is the meaning of advocacy? If there is any document prepared by the laboratory, it has to be checked whether it is fulfilling the requirement of the laboratory or not. Because if you are adding too many things and which are of no use, then document is not effective. So before approving that particular document, adequacy is required. Whenever you make a quality manual, quality procedure manual, standard operating procedure, or we can say testing or calibration method, they must be checked for their adequacy. Then only they will be approved by the authorized personnel. Documents are periodically reviewed and updated as necessary. Laboratory must have a plan for the periodical review of the documents, because many times it has been seen a particular standard is revised and laboratories are not having any knowledge about the revision and they are following the previous standard. So it is to be avoided. How they can avoid it? By the periodic review, they will come to know what is the change. For example, now 2017 version is in the use. Can anybody use 2005 version? No, nobody can use. So if there is a change in any document, for example, there is some specification for conducting a particular kind of testing or calibration, and it is revised, and in the revision it has been found that the temperature for the performance of a particular test previously was 20 degree, now it becomes 25 degree. So at that time that 25 degree has to be followed. If they don't have any idea about the revision of that particular document, they will still using 20 degree, then it's a NC. So periodical review is required to get aware about the revisions. And if there is any revision, that has to be updated. Then change and current version, current revision status of document are identified. You must identify what is the change version, what is the current version. If you don't have the procedure for identifying them, then there can be a chances of using the old or the previous standard. So laboratory must have a control mechanism for these kind of documents. If document is changed, that has to be identified or you can put obsolete stamp over there. Just to, if anybody will see, he will quickly come to know that this document is of no use. Relevant version of applicable document are available at the point of use where necessary, their distribution is controlled. So there are two things. One is document shall be available at the point of use. How? For example, somebody is performing calibration of a vernier caliper, calibration of a thermocouple. Then the procedure for calibration of vernier caliper must be there where the calibration is performed, because the person or calibration engineer or anybody who is responsible for the calibration, when he is performing the calibration, he must have standard operating procedure or calibration instruction at the table of the calibration where he is performing the calibration. Similarly, if somebody is performing calibration of, let's say, pressure gauge, so the procedure must be there at the table, because you can't remember all the things. Only by referring the particular document you will come to know what is to do, what is not to do. So they must be available at the point of use. Then distribution must be controlled. Which document is given to whom? Every time you have seen there is a distribution list, that who is responsible for what document is given to him. For example, quality manager is there, technical manager is there, calibration engineers, and then other people, those who are working in the laboratory. So there must be a distribution list and it must be controlled. Documents are uniquely identified. What is the meaning of uniquely identified? Can we give the same number to the quality manual, to the quality procedure manual? No, we cannot. The number must be uniquely identified. For example, why names are given to the different people? To identify them uniquely. So all the documents must be identified uniquely. If there is a quality procedure manual, there are 9 procedures, they must be uniquely identified. If there are 50 forms and format, they must be uniquely identified. They must have revision number, they must have revision date, issue number, issue date, approving authority, issuing authority. So they must be uniquely identified.
मैंने बोला है कि आपके इंटरनेट कनेक्टिविटी का इशू होगा, लेकिन मेरा इंटरनेट फाइन है.
Now, the unintended use of obsolete document is prevented. Very clearly written. The obsolete document cannot be used and their use must be prevented. And suitable identification is applied to them. If there is any document which is obsolete, that must be identified.
I think somebody's mic is open. Please kindly close the mic. Thank you.
Suitable identification is applied on the obsolete documents, because if you have put the obsolete stamp over that particular document, you will come to know this document is only for the reference. Why we keep the documents? For the future reference. For example, today we want to compare 17025 2005 and 2017. Then we can compare what was the difference, what is the difference in the number of procedures. For that purpose, we keep all the documents for the future reference and they must be identified. It must have obsolete document, obsolete stamp or the document on the front page, so that if somebody will come across with that document, he will come to know that this document is obsolete document and it is for the future reference. And these documents, in what way we can control these documents? We can control these documents by putting issue number, issue date, revision number, revision date, approving authority and issuing authority. And the document must be signed by the approving and issuing authority, so that it is confirmed that the particular document is the authentic document. If there is no stamp, no signature, then this document cannot be considered as the control document. Now 8.4, control of record. We have discussed about many documents like quality manual, quality procedure manual, work instructions, forms and format. So if we see in this particular standard, there are more than 15 clauses where the standard speaks about record to be retained, like this. So there are many records. If we start from 4.1, there is a record of impartiality and confidentiality, that the employees, those who are working in the laboratory, they have to give the declaration that they will maintain confidentiality, they will maintain impartiality. Once they will perform testing or calibration, they will be impartial. So they are giving declaration. So that is a record, because it will be different for different person. So now we will discuss about the control of these records. Laboratory shall establish and retain eligible records. Eligible record to demonstrate fulfillment of the requirement in this document. The records or control of record is basically the requirement of this particular document. They must be legible. Legible means you must be able to read them, and they must be retained. So all the documents, all the records which are available with the laboratory, they must be legible, and there must not be any situation where you are not able to read those documents. For example, there is a observation sheet, and due to some happening there, you are not able to read the observations. So they must be legible. 8.4.2, the laboratory shall implement the control needed for identification. So how you can control these records? Number one, they must be identified. For example, I am talking about the training record of the personnel. So when I am talking about the training record of a personnel, it must contain the name of the personnel, employee code of the personnel, what kind of training, on which date, who was the faculty, who was the institute. So it must be identified. Then storage. All the records, they must be stored. Because if you don't have a procedure for storing them, then you may lose your records. Protection means you have to protect them. For example, you have stored the records, and you have not taken the precautions from the insects, or due to the humidity, the records, they get damaged. So you have to protect them. Then backup plan is also there. Now you have the hard copy, and because of some reason there is a fire in your laboratory and all the records are damaged. What will you do? So you must have backup plan. How you can have a backup plan? For the records which are available online or digitally, you can keep them at 2 or 3 places. You can have backup. You can have a separate backup. For hard copies, you can scan them and you can keep them in a folder. Then archive. Retrieval means you want to retrieve a particular record at some point of time. For example, you are facing assessment and assessor is asking for the training record or for the environmental record, and he is asking, for example, today is April 24th, and he is asking about the record of temperature in the month of December. So it must be retrievable. Then retention time, up to what time you will retain these records. Laboratories usually have retention time. For example, they will retain reports for 3 years, and other documents for 3 years, some documents for 2 years, some records for 2 years. So there must be a retention time of the records. Then disposal of these records, because you cannot keep them for whole life. The records, for example, you are having more than 50 type of records, because you are having 50 formats. So all are the records, because you are filling those formats for so many things. So it is up to the laboratory that they will fix the retention time, and after a particular time they will dispose of these documents, these records. Again and again I am speaking document, but these are records. Then laboratory shall retain record of for a period consistent with its contractual and legal obligations. For example, there is a laboratory, they are having a registration number as per the Company Act. So this is also a record that has to be kept for the whole life. And any contract with some client, that has to be kept for the till the time of the contract. So there are some records which needs to be maintained for legal obligations or contractual obligations. Access to these records shall be consistent with the confidentiality commitment, and records shall be readily available. What is the meaning of confidentiality commitment? For example, a laboratory is performing calibration and testing for many clients, and out of these clients, for example, two clients are competitors, and one is trying to get the result of testing of a particular equipment manufactured by that particular client. And laboratory people know about the in and out of the product manufactured by their customer. So the data, the performance has to be kept confidential by the laboratory personnel. They cannot reveal the data of one customer to another customer. And these records shall be readily available. Readily available means if somebody is asking for some record, you must have the ability to show it. It is not like that he is asking at 1 o'clock and you are not able to produce that particular record till 4 o'clock. It means there is a failure. Within 5 to 10 minutes, or I can say within 2 minutes, record must be available. So all the records which are kept by the laboratory, they must be readily available. Now the risk and opportunity will be taken care by Warren Morkel sir. So I am leaving this clause 8.5. Now we will discuss about 8.6 improvement. If you see, the improvement is really required, particularly in the field of science and innovation. I can take the example of which is definitely out of the laboratory, because I am just taking the example of cars. The cars manufactured by the Japanese and cars manufactured by the Americans. The Japanese have made continual improvement in their product. Similarly, we have to apply improvement in the operations of the laboratory. What laboratory is performing, how they are performing, how their management system is, how their technical capability is. So improvement can be applied everywhere in the operation of the laboratory. 8.6.1, the laboratory shall identify and select opportunities for improvement and implement any necessary action. They have to see, the laboratory has to see the opportunities for the improvement. The opportunity for improvement can be identified through the review of operation procedure. Operation procedure means the procedure which are followed by laboratory for the operation of the laboratory for various kind of testing and calibration. Then use of policies. Policies means the vision of the laboratory. Basically, every laboratory is having a quality policy. What is that? It is basically nothing. It is a vision. It is vision for 15 years, for 10 years. Then overall objective. Objective are nothing but they are part of the policies. But they are for short term. For policies are set for 10 years. Objective may be set for 3 years, 2 years, or 1 year. So objectives are also the part of policies. And overall objective has to be taken care how they can improve these objectives, how they can improve the system to attain these objectives. Then audit result. Whenever a laboratory face any type of audit, whether it's an internal audit or whether it's a external audit by the accreditation body or by any client or any customer or any regulator. So the outcome of the audit means there may be some observations, some ANSIs raised by the customer or by the accreditation body. They can see and they can improve over these ANSIs so that in future the same kind of problem may not come. Then corrective action. The corrective actions which are taken by the laboratory. If you see, there are ANSI raised by the accreditation body or by some customer or by some regulator. So the corrective action, how they can improve? By referring the corrective actions. Then management review. Management will be taken care in 8.9, but it is really required because management review is the review of the whole system of the laboratory, starting from the top management to the objectives, to the policies, to the technical capability and feedbacks, complaints. So they can, by referring management review meetings, they can think over how they can improve their system. Suggestion from the personnel, because there are many people working in the laboratory. They may give suggestions. So it will be better that if laboratory may use the suggestion box and fortnightly or monthly, they can review this suggestion box and they can improve upon the operations of the laboratory. The risk assessment. Basically, whenever you perform any task, there is risk associated. For example, you are performing calibration of even class weight by the with the help of the balance of 0.1 microgram. So there is a risk because you may get even class uncertainty or you may not get even class uncertainty. To avoid this risk, how you can improve your system? You can have a ultra micro balance, which is 0.01 microgram. So in this way, you can improve your system by the risk assessment, analysis of data. The laboratory is having a lot of data. Laboratory is having the data of complaint, data of feedback, then the result, then the reports issued to the various customers. They can review them periodically. They can review them and they can find how they can improve. If they are getting feedback that the laboratory is not giving prompt service and there is a delay in their reporting, they can think over it. If they think if they are getting feedback that laboratory is not able to give the prompt service for the calibration at site, they can think sometime. For example, one laboratory is having only one pressure comparator and every day they are getting two sites, so they can purchase one more pressure comparator so that they can provide the service timely. Then the proficiency testing result. If laboratory has participated in the proficiency testing, they can see their results. In case of calibration, the EN ratio must be within 1 plus minus 1, and for Z score, it should be less than 1, less than 2. So on the basis of your performance, if you are getting out in the EN ratio, then you can think why you have you are outlier. Sometime it had happened the laboratory has given the wrong uncertainty. Wrong uncertainty means their uncertainty was 0.01 and they by mistake they have given 0.013 and they are getting EN ratio 1.1. So they are failed. So you have to be very careful. So this is basically for the improvement. Small things can be very fatal to your laboratory. Then 8.6.2, laboratory shall seek feedback. Shall is used over there. So whenever you perform any task for any customer, you must have to get feedback. I'm not saying that you have to take 100% feedback, but at least you have to take feedback so that you may analyze those feedbacks, both positive and negative from its customers. Feedback can be positive or feedback can be negative. If some customer is giving you the feedback, it can be positive, it can be negative. It is up to the laboratory how the laboratory respond to the feedback. In case of positive feedback, it's perfectly fine. Maybe you don't require any action. But whenever there is a negative feedback, you have to think over it. The feedback shall be analyzed and used to improve the management system, laboratory activities, and customer service. So basically, whenever you make the system for feedback, you add those points in the feedback which are required to improve your operation. What basically customer wants from you? How is the service of your laboratory? whether the customer is satisfied or not, what is the technical competency of the laboratory, whether he is satisfied with the CMC or not. So the laboratory can think how they will prepare their customer feedback format. Example, the type of feedback include customer satisfaction survey. You may do the survey for your customers, communication record and review of reports with the customer. Communication which you perform with your customers or with the people, those who want to get your service. Many times the laboratory get inquiry from the customer. So these type of communication needs to be retained, because for example somebody has asked for the calibration of SPRT, and that particular laboratory is not able to perform the calibration of SPRT because of the CMC or because of the availability of the instruments. So with reference to that particular communication, the laboratory can improve their working capability. They can acquire the calibration equipments which can calibrate the SPRT. So based on the various type of communication with the customer, they can improve their technical capabilities, they can enhance their scope. Also, the reports which are issued to the various customer, they need to be reviewed. For example, you are having a format for reporting of testing and calibration, and you have faced the assessment also, and there is no NC, but still you can review that particular format. What extra you can add in that particular format so that it can be more informative to the customer. So periodic review of these records can always help in the improvement of the operation of the laboratory. Now we will discuss about the corrective action. Corrective action is basically whenever there is any deviation from the laid down policy and procedure or the requirement of the standard. And whenever there is any deviation, any error, then you need to correct it, and you need to correct it in such a way that it may not happen again. So the corrective action is the action by which you will remove that deviation and it may not happen again in the future. So when non-conformity occurs, the laboratory shall react to the non-conformity as applicable. And before going into the detail of corrective action, I would like to discuss about the non-conformity. As I have already discussed about the what is non-conformity, but there is a type of non-conformity, whether it's a major non-conformity or whether it's a minor non-conformity. The meaning of non-conformity is when there is a total system failure. There is nothing, everything is fail in the laboratory. The documents are not retrievable, and the people are even not competent. They have not performed PTILC, they have not performed internal audit. So there is a total system failure. System is collapsed. In that case, this non-conformity will be major non-conformity. Second thing is, if the particular deviation is affecting the result of the laboratory, testing or calibration result of the laboratory, then it is a major non-conformity. Third type, if a similar kind of non-conformity is coming again and again, then it's a major non-conformity. Other than these three non-conformities, all are minor non-conformity. So whenever you segregate the non-conformities, you have to keep in mind that which kind of non-conformity will be major and which kind of non-conformity will be minor. Now, react to non-conformity as applicable. Take action to control and correct it. The first action is to take action and correct it and address the consequences. what will be the consequences of that particular deviation which is found in the system. For example, a laboratory is having the two digital pressure gauges. Both the digital pressure gauges are of same range, same list count and same make, but they are having the different serial number. They are also having the different deviation in their calibration report. And one pressure gauge is having deviation more than 0.5%, for example, and one is having 0.3%, and one customer came to you and he wants the calibration less than 0.3%, and in that particular case you have used the pressure gauge of 0.5%. So this is a non-conformity because you have to perform calibration with the help of 0.3%, and you are reviewing that particular report. You came to know that you have done wrong reporting. In that case, you will raise the NC as per 7.10. Madam Sangeeta will take that particular clause. You have to call back the report. You have to again call back the equipment, and again you need to calibrate it. So this is the corrective action. Correction can be done instantly, but the corrective action shall be in such a way that it may not happen again. However, sometime it happened. You have taken the corrective action, but again, same kind of NC is occurring. So you have to see you have to look very carefully, and you have to see the root cause of the non-conformity. If you are able to find out the root cause of the non-conformity, I am sure that it will never again in future. But if you are not able to find out the proper root cause, then it may happen again. Now 8.7.1b, evaluate the need of action to eliminate the cause. You have to evaluate the action, how to eliminate the cause of the non-conformity in order that it does not reoccur or occur elsewhere. For example, some non-conformity is occur in thermal section. Thermal section means thermal calibration. You have to take corrective action in such a way that it may not happen in mass calibration or in electrotechnical calibration. If there is any NC, for example, due to temperature variation, there is a NC in dimension, and whenever you are performing calibration of pressure, same non-conformity may occur. So you have to take corrective action in such a way that if you are implementing corrective action in one section, it should automatically implemented in all the other sections. Now, reviewing and analyzing the non-conformity. You have to review that non-conformity. You have to analyze that non-conformity. Why this non-conformity is happened, and what was the reason? Determining the cause of non-conformity. The cause means the root cause, from where it occurred. What was the reason? The people, those who are working in the laboratory, they know very well that from where that non-conformity is coming, how they can remove it, what kind of corrective action they can take so that it may not happen again. Determining if similar non-conformities exist or could potentially occur. So you have to see the potential of occurrence of similar kind of non-conformity. If you are not able to find out the potentiality of the reoccurrence of the non-conformity, then it will be very difficult to stop the similar kind of non-conformity will not happen again in the future. Now implement any action needed. Basically, whenever you take corrective action, so you think broadly in what way you will implement the corrective action, what are the other parameters which can cause non-conformity, What can be the consequences? Then review the effectiveness of any corrective action taken. For example, you have taken the corrective action. Then you have to plan after what time you will review. You will see the effectiveness of a particular corrective action. If you are just fulfilling the requirement of this document, just to fulfill the requirement of the audit or just to show in the audit, then it is of no use. It will be useful only. It will be useful only once you are taking that corrective action, so that the similar kind of non-conformity will not reoccur or will not again occur in any of the department or in any of the operation of the laboratory. Update risk and opportunity determined during planning if necessary. Whenever you plan any corrective action, you have to see the risk associated with that particular kind of corrective action, and you have to see the opportunity. Opportunity can be the improvement in the system. Opportunity can be the good reporting for the customers. And what is the risk? Many times there can be a risk, because if you have performed calibration by the equipment which was not calibrated due to oversight, and you have issued the 100 of reports, then it's a big task. You have to call them again and you have to calibrate them, because you don't know whether your particular instrument was under the permissible limit or not. So in that case, it is really not possible to call back 100 equipments. What will be the perfect action in that particular case? You get it calibrated, then review what is the deviation. If deviation is under the permissible limit, then it is not required to call all the equipments. You may raise the NC, this particular equipment was not calibrated and we have calibrated this much of equipment. After that, we have taken the corrective action, we got it calibrated, and we found that the particular equipment is under the permissible limit. But in this case, you have to change the report, because you have written the instrument which you have used is already expired. So you have to think from this point of view, how you can see the risk associated with the particular corrective action and the opportunities. Make changes to the management system if necessary. If you see there is any process in your laboratory which is causing non-conformities, then you need to change that particular process or that particular procedure. The corrective actions shall be appropriate to the effect of the non-conformities encountered. The corrective actions must be effective. If you are just taking the corrective action for the sake of the fulfillment of this particular document, then it is of no use. How it will be useful? You take the corrective action so that it is very effective and you are not getting similar kind of non-conformity in the future. Now 8.7.3, the laboratory shall record as evidence. As we have already discussed, what are the records? Records are nothing but they are the evidence of a particular activity or a particular happening. We have already discussed nature of non-conformity. We have already discussed about the nature of non-conformity. Nature is nothing but whether it's a minor or major. And we have already discussed what is the meaning of major non-conformity and what is the meaning of minor non-conformity. If assessor is observing that you have written wrong date, it's a minor non-conformity. If assessor is observing that you are not taking the correction factor, and correction factor is crucial for the final result, then it's a major non-conformity. So whenever you talk about the record of corrective actions, basically there is a format which is for corrective action of the non-conformity. So you have to mention each and everything over there, that date of non-conformity, clause, major and minor, and root cause, or it is written here only cause, the cause of the non-conformity, then subsequent corrective action, what the corrective action has been taken by the laboratory to remove that particular non-conformity, whether it's a major or minor. Because until and unless you will not take the corrective action to remove it, it is of no use. Then result of any corrective action, basically the corrective action you have taken in your laboratory, then what are the result? How you will come to know the result? You will come to know the result after taking the corrective action, and once you will review. For example, there were 5 non-conformities, and after 6 months you have reviewed those corrective actions, and you find there is no non-conformity similar to these non-conformities. It means that your corrective action is perfectly fine. But if you are finding that out of 5 you are getting 2 non-conformities of similar kind, it means there is some gap. You have to find out that gap. You have to remove that gap. So basically, whenever you take any corrective action, there shall be a format for the corrective action, and that format must contain all the relative parameters of corrective action. And it will be better if you can add one more column or row in the corrective action report, the review of corrective action after 6 months. So it will improve your effectivity, it will improve your efficiency, because once you will get less number of non-conformity, it means that your system is working perfectly. Yes, sir. So now we have discussed about these 4 clauses, 8.3, 8.4, 8.6 and 8.7. So I think we have discussed each and everything. If there is any question, we will reply that question during the time of question answer session. So thank you very much, sir.
Thank you very much, sir, for your clearly explaining all these clauses of the standard. Many of our participants are asking the presentations. I will try to give you the best presentation. Don't worry, just give us some time. Because in this standard, what we will give you in the presentation, we will just put one part or one line or one clause in one slide, nothing else. This will be the only type, say how we used to do the presentation or how we are making the presentations. Even after, I will try with my all panelists to kindly prepare the presentations with examples on the slide itself, so that anybody can understand what is the meaning of the clause. Even after, by tomorrow or by today evening, you will get all my participants these presentations either through the WhatsApp group or through the mails. Whosoever have attended these 2 programs, whosoever attended these programs for 2 days, they will be continuously informed about the programs through mail or WhatsApp. What are the next we are doing? Immediately after this program, I am also planning to have one training program for 2 days on ISO 15189, which is for all type of medical laboratories, not only medical laboratories, because it's a requirement of the country. And as you are working in this particular field, how you can think of it to work better in the medical field where there is a need of an R. Thank you very much, Bhatta Singh Sahab. Thank you very much, Anil Kumar ji, and next Sangeeta ma'am, who were actually the panelists today. Now we will be meeting at 2 o'clock, because we have started at 10:30, half an hour early. I hope that by 4:15 or maximum by 4:30, we will try to finish it. Actually, I'm not able to speak during these, as we have the actually experts from the field. They are the learned people, learned persons from the field, and I don't want to waste the time. Thank you very much all. Now we are meeting at 2 o'clock. Even before 15 minutes, we will start. Maybe quarter to 2, we will start, and you can join. Thank you very much. After lunch, 1:45, we are again meeting. We will start our session from 2 o'clock. Thank you very much. Thank you all. Good afternoon to all. Thank you very much for the fourth and the last session, which we will try to finish by 4:15 or maximum by 4:30. Under this session, we have with us Ms. Sangeeta Negi, who will explain the clauses 6.1, 6.6, 7.1 and 7.3. Thank you very much, ma'am. We request you to kindly start, and as we have already explained yesterday, you are having a lot of experience in accreditation and other services. Thank you very much. You kindly start with these clauses 6.6, 7.1 and 7.3. Thank you very much. Over to you.
Just a second. So its clauses are 7.10, 7.11, 8.1, 8.2.
I'm sorry.
Just to correct.
I'm sorry.
No
I
worries,
was spoken
no
of
worries.
yesterday's clause. I'm sorry. Your clauses for
No
today
worries.
is 7.10, 7.11, 8.1 and 8.2. I'm so sorry. Yeah, please
No
start.
worries.
Thank you very much. Thank you.
Thank you, Ashutosh, for giving this opportunity. I hope everybody has a good lunch break, and now we'll go ahead with these clauses. I've already discussed that it is 7.10, 11, and 8.1 and 8.2. So just a recap of what is the standards is all about. As I last time also said, we need to have a clarity from top to bottom. We need to approach activities from top to bottom. First thing first, what exactly we are supposed to do? We are supposed to do is as a testing or calibration laboratory, testing a product or calibrating an equipment and giving an accurate and reliable result. That is a key activity. Around it, everything falls. So now for that, just to ensure that we get the accurate and reliable results, we need to have a structure around it, be it resources, be it facilities and other things. So if you look at the standard, there are clauses, for example, I'll give you the overview so that we don't miss the larger objective. So when it is, if you look at the standard, clause 4, which says the general requirement, speaks about the impartiality and confidentiality. When it comes to section 5, which is, gives the structure requirement, which talks about basic requirement like legal identity, etc. Then comes the section 6, which talks about the resource requirement, which is having 6 clauses. So which has, personal, facility, equipment, system, and also supplier support services. And comes the 7th clause, which is a process requirement, which talks about 11 core processes for improving the efficiency. So here, and then the 8th is the management system requirement. If you look at in a holistic manner, you'll realize that every aspect has been touched upon by the standards, just so that it ensures the quality of the results. As I repeatedly been saying that accurate and reliable result. Not only once accurate, but it should be reliable. It is repetitively accurate. So that kind of thing. So now comes now I'll come down to next level is that 7th process requirement, which I'll be dealing with this. It's 7.10, which talks about the non-conforming work. And in the meantime, I'll just miss that clause 8 also, which talks about the managed system requirement. Since this standard has been this time reviewed as per and it's been made in line with the 9001, which talks about the management system requirement as well. So it's 17025 has given 2 options, option A, option B, which is with respect to the management system. If any organization if is having 9001 and the lab is a part of it, so then the management requirement is met by that, and other technical requirement with respect to laboratory can be met, and then the laboratory will be considered as a compliant with 17025. So that laboratory need not to go for those system requirement, management system requirement, if it's already accredited by 9001. So this is a broad rate. I'll go down to the clause 7. So for the clause 7, it is non-conforming work. What is non-conforming work? If you look at the in general notion, also whatever activity you do at home or offices, you sometimes miss the target, or happen to commit a mistake or whatever reason. So this is similar to that. If you're doing some activity in lab, there is a non-conforming work which might happen. This could be because of the this could be when this could be because of the the laboratory is not able to comply with the 17025 requirement or its own lab procedure or the customer requirement. Then it becomes a non-conforming work. So goes without saying, it's very, very critical to address that part. So when you say anything is critical to the activity for the laboratory, then it has to have the procedure for that. So when we say shell, laboratory shell, if you look at the slide 7.10.1, it's a laboratory shall have procedure. So we should, the laboratory should have a procedure for non-conforming or wherein shall have a procedure that shall be implemented when any aspect of its laboratory activity or result of its work do not conform to its own procedures or agreed requirement of the customer, as I already said, or the agreed requirement or the 17025 clause. The procedure shall ensure who will be responsible and having the authority of management of non-conforming, because you need to have somebody who will be responsible for acting upon that. It needs to be clearly mentioned that when this happens and a non-conforming work takes place, who will be responsible for doing what. It should not be nobody is aware who will be responsible, and it should clearly be mentioned so that anybody who comes to know and sees the document and realize that a person A is the person who need to do this activity and who is accountable for that. Another part is action. So it should have ensure that action, including halting or repeating of work and withholding of the reports as necessary, are based upon the risk levels established by the laboratory. So by now you all must be aware this standard is based on the risk management process and this risk management has been taken up in place of the preventive action which was there in the earlier version, 2005 version. So whatever activity you do under the standard needs to be done with risk assessment process. You need to have established what are the risks on that, and accordingly act upon that and address that. So that was it. And then there is another one is, so this procedure shall ensure that evaluation is made of the significance of non-conforming work, including an impact analysis on previous result. Makes sense. If there is some non-conforming work happened, where the result was not correct, then you need to find out what was the reason for it. This evaluation can go to any deeper level of doing the kappa, or doing the root cause analysis in kappa, and then going for that. So you need to find out and do the trail also, how exactly it's been happening. Suppose when there was a result was given from an equipment, and you need to find out what was the earlier trend. So you need to see what exactly was happening, and then also impact analysis of those results also. So next part is decision is take on acceptability of the non-conforming work. So it should be there, about the decision, and it's been accepted. And then where necessary, the customer is notified and work is recalled. So obviously sometimes this could be a scenario that probably, for example, you have participated in PT and found out that result was outlier, way too outlier. And you realize last month only you have given a report based on that equipment. And when you were doing the root cause analysis, you realize that equipment was the issue. So you need to communicate the information to the customer as well about what has happened for this, and you might need to recall that result also. So that this is one example. Another could be, anything you feel that it was not correct, you need to recall. So that needs to be notified to the customer. The responsibility for authorizing the assumption of work is defined. So once there is a non-conformity, you have already mentioned in a procedure who will be responsible, what action will be taken, kind of root cause impact analysis, who will be notifying, and how it will be notified to the customer. And then once it is done, correction is done, then who will be responsible for authorizing the resumption of work? So because you might need to halt that activity. So once you halt, then to restart, somebody has to reauthorize it. The next part is 7.10.2 is the laboratory shall retain a record. As I already said, whenever there's a procedure, you should ensure that you retain a record also. That is essential, but over and above, you can also do other clauses as well. But again, I said as a retain a record. it's not, as I always say, don't look at from the auditing perspective. Somebody will come as an auditor and see the trail, look for the record. No, that is just a part of it, just a offshoot of this whole activity. The point is, you should have that record to see what has exactly happened in the past, how you have taken action, if that was appropriate. Maybe in future something relevant related to that might happen, and you have to go back and see the record, see the document, accordingly make a decision. So this is not, I always say, don't focus on audit. It's more about improving the performance of the laboratory. So what all can help is there in the standard, and look at that from that perspective. Another part is 710.3, where the evaluation indicate that non-conforming work would recur, or that there is a doubt about the conformity of the laboratory's operation with its own management system. Laboratory shall implement corrective action. As I already mentioned, this makes sense. If you feel that corrective action is when you take something you want to avoid, there's something which has happened, you want to avoid recurring. So you take the corrective action just to ensure it doesn't happen. So it's it's not same as correction. So it's a corrective action when you do root cause analysis and correct it. And when you look at it, this is being linked to the clauses, clause 8.5, action to address risk and opportunity, and 8.7, corrective actions. So it's clearly evident here. Here we say corrective action, this clause, and then earlier we talked about the risk. So this discusses in 8.5 also. Now I'll come to the 7.11, control of data and information management. In the today's world, when focal point is the focal point is the electronic age. We have data in electronic format. It's more than regular affair now, having data in, electronic format rather than, hard copy or something. So it's become very, very essential to control that data and information management. So, but then clarity should be sought that what exactly is data and what is information. When we talk about the data, what is data? Data is anything, any fact about any object, entity, item, or anything perceivable, anything can be the data. But if you make sense out of the data become information. I mean, when the data is meaningful, when it is connected, correlated, you get some information out of it and eventually take the decision. See, the key part is making a decision out of it. Then it becomes information if you are getting that information out of it. So that's also, so not the data, but information is very, very critical. So, but here when we say 7.11, control of data, so unless we have a clarity about how data has been controlled, will not be able to manage the information. So this clause talks about that data information management, right? And then it is, and of course, this is a primary input and output for all these 17025 activity. If you look around it, 17025 activities, you'll get to know that everything is data, everything, and most of it can be made information out of it, right? So that's why it becomes very, very critical to manage that data and information. So there should be a clear management of data and information. So now this clause says laboratory shall have access to data and information needed to perform laboratory activities. It makes sense. Clearly, if you are doing some testing activity, you should be aware what exactly is relevant for that activity. So the laboratory shall have access to that data and information. Then second part is this include instruction manual and also all the instruction SOPs. These are obviously required while you're doing the laboratory activities. This is one of the example. And then validate laboratory information management system. When we say when we are using any product at home also, we look for fitness of the purpose, right? If it is worth doing worth for that activities, even if you are doing fridge, be it car, if it is fit for that purpose. So nowadays, since data information is so critical, many laboratories are using laboratory information management system. For that, it's critical to validate that laboratory information management system. Now, what do you mean by validating anything? Validating is checking the fitness for the purpose. In a layman's side, that layman's word, that it does what it is supposed to be doing. So if we are talking about laboratory information management system, of course, it needs to manage the information appropriately as per the requirement. So when you validate laboratory information management system, it should be done for functionality, what all needs to be done, what I as a laboratory have opted for the functionality before introduction. Makes sense, you should be aware. Even if you buy a car, you'll check before really using it for your purpose that it is working or not. You'll go for a trial. You see that kind of thing. So you need before the introduction, you should know that it is work. This is functionality is valid for you, is fit for purpose for you. And then before introduction, if used for collection, processing, recording, reporting, storage, or retrieval data. So these are the key aspects of the laboratory information management system, which is collection of data, of course, and processing of data, recording of the data, reporting, storage, and retrieval. And all of them are key to the 170225 activities. So nowadays, most of the time, laboratory information management system is being supplied by the supplier, and then they themselves validate it. So that becomes, but you need to have that kind of information with you if you're using it, if it has been done, operational validation has been done, performance validation has been done, installation validation has been done. When it is installed, it was at the requirement, and operation validation when you see when it's operating well as per the requirement, and performance performing as expected. So this was it. Any changes, including configuration or modification, shall be authorized, documented, validated before implemented. Again, makes sense. If you're changing your car by, something you're changing, it should, you should know before you again using it, again driving it, that it is clearly, uh, uh, it clearly still is fit for the purpose. So any changes, including configuration and modification, shall be authorized. Who is doing it and should be documented. Documented word whenever it comes, it should not be taken as a something menial task, which needs to be done for the heck of auditing or other purpose. No, it is for the purpose of having a trail for your own sake, for making a decision on it. Knowing the trends, that kind of thing you should know, and validated before implementation. So as I said before, of course, using it, you would like to get it validated for its fitness or purpose. There might be a chance that you got it modified, but still it's not working efficiently, So you need to do that validation before implementation. Next comes the 7.11.3, which says laboratory information management system shall be protected from unauthorized access. As I said, when I say it's very, very critical to have that information, it's very critical for operation of a laboratory. So of course, you would like not to have this access to anybody. So only those who are authorized have the access. So you can have a password protected, or you have your own means to ensure that nobody else accesses it. You have a car, if you would not want anybody to drive it for you, who is you're not who you don't want them to. So that needs to be done that way, and then be safeguarded against tampering and loss. So it should be safeguarded, especially for the information nowadays. It might crash, the system can crash, there could be hacking, there could be anything, these days. So you need to safeguard. If you lose the data, it'll impact the whole system. So that needs to be safeguarded. You should have, maybe antivirus or other facilities. Be operated in an environment that complies with supplier or laboratory specification, or in case of non-computerized system, provide condition which safeguard the accuracy of manual recording and transcription. So this is logical. You need to have, since you're working for a supplier, since you're working in that condition, it should be complies with suppliers or laboratory specifications. Of course, as an buyer or as a supplier, you should have that environment to do that. And for the non-computerized system, of course, you need to have that safeguard the accuracy of manual recording and transcription. Now comes the next part is be maintained in a manner that ensure integrity of data information. You got the information management system, you've been recording that information therein. How do you maintain it? It's again important thing. Can it be first? Can it be changed? Do you have a timestamp if something has been changed? Do you have the you can see the author who has accessed the data? So that kind of thing, you should ensure the integrity of the data and information. That's very important. And also include recording system failures and the appropriate immediate and corrective action. If anything happens, you should be able to record why the system has failed and what are the action you have taken. So this is again shell. So you have to have that documented. The next part is control of data and information management. As with the previous requirement, the laboratory is responsible for information management system, whether it is in the laboratory facility or maintained elsewhere. So that is goes without saying, if laboratory is doing some activity, testing a product, giving a result, and maintaining related to that data in an information management system, laboratory is responsible for it. Because when you want to trail it, it has to have somebody has to be responsible, laboratory has to be responsible for that. And then instruction manual and reference data relevant to the laboratory information system readily available to the personnel. Of course, for doing their activity, for knowing the information, how this organization is set up and what are the objective or policy and other things. So the personnel need to have that information readily available. It should not be like, it should be kept in the store and somebody is working on the desk or in the lab and they are not aware of the SOPs and they're doing by memory. So many a time memory fails us. So you should have access to the information directly as and when they want, as and when somebody wants to access. So this was information management system. Now, since it is very, very critical, it's been related to other clauses as well. For example, 8.2, which says about management system documentation, well, we are talking about it. And then clause 8.3, control of management system documentation, and 8.4, control of record, and clause 7.5, technical record. So you can make out, how this, if we are talking about information, so manual is also information, instruction is also information. So 8.2 discusses about it, and then 8.3 talks about control of management system documents. So those documents need to be controlled. It cannot be unauthorized, uncontrolled version of anything, and or old or obsolete. And then the control of record, since this generate a record, so it needs to be recorded. There has to be record control, and then the technical record, which talks we talking about talk in the clause 7.5. So this technical record is also related to this clause. Then comes the management system requirement. So as I told you, top to bottom, system resource, and now this management system. So structural requirement, and then now the management system requirement. When we talk about management system requirement, is first and foremost we should be clear about what is system management system. Management system is nothing but all the activity, all the process which are interrelated is there, and considered as a system, not as an individual process. So any activity, be it the testing, be it external supplier, be it, training, anything which is related to core activity is the part of it. And it is written down, then it become that is there. So when we say management system, the purpose is ensure overall structure of the management system is in place in support of the policy and objectives of lab. So we see in the beginning there is a mention of the policy and the objective. Policy is nothing but the intent of the organization formally written down by the top management. So it says that this is the policy of the laboratory, and the objective is, uh, objectives are, those target which we want to reach. So that needs to this management system requirement purpose is to support those, and it encompasses control of documentation, data and information, management system performance evaluation, and improvement processes. This requirement has those things. So now, as I said about the new standard 17025 2017 version, that it is now in line with the other ISO standard. For example, 9001 2015, which has those kind of requirement. Earlier there was a sometimes there were confusion because 17025 has different set of requirement. Vis-a-vis 9001, though they were the ISO standard, they were talking about the management system. The only thing over the baseline was only thing different in 17025 should have been only the technical requirement relevant to the lab. Now they have made it a point that it is aligned to all the ISO standard. So when it comes to 9001, it is management system requirement for an organization. So it has all the management system requirement. If any organization complies with it, has all the consistency. But then if a lab is a part of that larger organization, it is already certified as per 9001, it has all the management system requirement in place. Only part needs to be compliant is the clauses with respect to the laboratory. So, and then if that laboratory can comply those requirements specific to the laboratory, then it can be considered as compliant with 17025. Not specifically mentioned that those are the management system requirement is followed. So this has been segregated. They have been provided two options. If lab is a part of larger organization having 9001 accreditation or certification, and if lab is a standalone independent entity which is not certified as 9001, so then what should be the requirement when it comes to management system? So we'll talk about it. So laboratory, when it comes to 8.1.1, laboratory shall establish, document, implement, and maintain a management system. So it says shall. So need to have that in place because again, it's very, very critical. Unless you have management system in place, all other activity will fall, around. So that needs to be there. It has to maintain a management system that is capable of supporting and demonstrating the consistent achievement of the requirement of this document. That is the key part, and assuring the quality of laboratory result in addition to meeting the requirement of clause 4 to 7. The laboratory shall implement a management system in accordance with option A or option B. So this is clause 4 to 7 is relevant for the laboratory activities. If it is clause A, that speaks about the management system, and if you opt option A or B, then accordingly you need to comply with the requirement. So when I said if you are part of larger organization, you need to meet clause 4 to 7. The rest are being compliant as per the ISO 9001 certification. So if you look for the option A, most of the time it happens that a laboratory stand alone and need and applying for accreditation as per 17025. So it doesn't have already existing management system. So if it is applying as per 17025 and doesn't have the existing management systems, so in that case, it will opt for option A, wherein it has to comply with the clause 4 to 7 along with this option A, management system requirement mentioned herein. So option A says, as a minimum, the management system of the laboratory shall address the following: management system documentation, of course, control of management system documents, control of record, actions to address risk and opportunities, improvement, corrective action, internal audit, management review. And then option B, as I already said, laboratory that has established and maintained a management system in accordance with the requirement of ISO 9001 and that is capable of supporting and demonstrating the consistent fulfillment of the requirement of clause 4 to 7 also fulfill at least the intent of requirement specified in 8.2 to 8.9. So it's already complying with the 8.2 to 8.9. So it just need to mention, just needs to convey that it is complying with clause 4 to 7. Option A, management system documentation. So we are talking about the management system documentation for the standard lab. So the clause 8.2.1 speaks about laboratory management system. Management shall establish, document and maintain policies and objective for the fulfillment of the purpose of this document, and shall ensure that the policy and objectives are acknowledged and implemented at all level of the laboratory organization. So it clearly says that first and foremost, we need to have that management system in place. We need to have the policy and objective. The top part is when you look at the pyramid of these of the documents, the top part is the policy. So that is the main point. What exactly the organization want to do, the broadly, formal commitment, and then formal objective, which is achievable. We do. So the laboratory want to be the top best performing lab could be one policy, but objective is achieving target, something like achieving 100% testing within 2 days, something like that. Those are achievable objective. So it flows from a policy to objective. So it needs to establish that have a clarity that this is the thing laboratory is supposed to do, and the personal, and once it has been established, so it should be acknowledged and implemented in all level of the laboratory organization. It means everybody should be aware of it. That's why we sometimes say, you should paste it on a wall, frame करके आप दीवार पे लगा दो, people can read it, that regular reminder that what is our policy and the objective. We should be aware you are supposed to do this. It's ready reckoner for you for your daily activities. So it should be acknowledged that everybody is aware of it. Then the policy and objective shall address the competence, impartiality, and consistent operation of the laboratory. So it makes sense when you are talking about it. It should have those. It should address the competence and impartiality, and because it's very critical. It's cornerstone. Impartiality is cornerstone of the standard. So it needs to address that, and it's a consistent operation of the laboratory. 8.2.3 talks about a laboratory management shall provide evidence of commitment to the development and implementation of the management system and to continually improving its effectiveness. Again, if I say the main activity is testing a product and giving reliable accurate result. So for that activity, you are developing this management system. So and implementing it. But once it is done, it's not that this will suffice for future purpose also. There would be changes, there could be anything. So you need to see that it's continually improving and its effectiveness. You cannot keep it for another 30 or 50 years, same thing. There could be changes which needs to be addressed. And laboratory shall provide the evidence, doing by maybe by management system reviews. You review what how is it effective? Is it effective? This management system is effective for the current need or not? Or maybe any activity you do. So that kind of thing, you need to provide that evidence. Top management's commitment could be seen from that. Then comes the 8.2.4. All documentation process system record related to the fulfillment of the requirement of this document shall be included in, reference from, or linked to the management system. So it's a clear, obvious thing. Anything related to this management system shall be included and linked. So anything, any activity you're doing, anything record you're maintaining, you need to link it. Then comes the 8.2.5. All personnel involved in laboratory activity shall have access to the parts of the management system documentation and related information that are applicable to their responsibility. So again, it makes sense unless you give the uh, facility or the resources to the person involved in any activity. Will not be you won't be able to expect the uh, complete performance from them. So it's simply it says that it needs to all the person involved need to have the access of those related documents, be it the manual, be it the SOPs, be it the work instruction, whatever. But they should have that. Every individual with respect to their job responsibility, they have to relevant access to the relevant documents. Then comes the 8.3 control of management system documents. So when you have a document, you need to have a control on that. So what do you mean by control? It should not be unauthorized changes. That should not be an obsolete available to ensure that anything which is available is current authorized version. So when it comes to 8.3.1, it says the laboratory shall control the document, internal and external, that relate to fulfillment of this international standard. So anything external document, internal could be your manual, your procedures, your SOPs, and so on and so forth. But and for the external could be ASTM, ISO methods, list of that. You need to have that control of the document. In a note, in this context, documents can be policy statements, procedures, specification, manufacturer's instruction, calibration table, chart, textbooks, posters, notices, memoranda, drawing, plan, etc. These can be on various media, such as hard copy or digital. Goes without saying. That itself explains what is the document here. Now comes the 8.3 control of management system document. Option A. The laboratory shall ensure. Now it is mandatory. Shall means mandatory. Documents are approved for adequacy prior to issued by the authorized person. So whosoever approves, whosoever releases this document needs to be issued by the person should be authorized, and it should be checked that it is adequate for the purpose, fit for the purpose, I would say. So that needs to be done. Documents are periodically reviewed and updated as necessary. As I said earlier, we need to continually check or review our system, that is it effective or for our purpose, is it fit for our purpose. So based on there in the from there it comes that documents also need to be periodically reviewed and updated. So there might be changes in terms of policy, maybe an objective, maybe your structure, maybe scope, anything. So need to see all those things. Changes in the current revision status of documents are identified. That needs to be clearly there. There are instances I've seen in organization that you have a document, but it doesn't have mentions, is it a current or last? The person is using that same one without knowing the fact it's a current or obsolete. So that information should be there, clearly identified, because otherwise, he or she will continue using that. So earlier there was, we used to have obsolete mention, those kind of things. Not necessarily do that, but stamping. But yeah, you need to mention, identify clearly that it is a current or not. Then comes the relevant version of applicable documents are available at point of use, and where necessary, the distribution is controlled. So again, it says, suppose if I need, I'm testing a product, I'm the one who is testing. So I should have access to SOP. It should not be kept somewhere in the reception or at the storage. So it should be readily available. No, so that needs to be there at the point of use, and where necessary, their distribution is controlled. It should not be just like that given to everybody. It should be controlled who has got the that document, and if it is the current one, and it should be clearly identified. And then documents are uniquely identified. It should not be same number or name is given to two documents. It causes confusion. And if some number is not there, because last when I was auditing, I realized that there were number given to in the manual to a document, but then it was not available. You need to clearly understand that it is not, we are not using the delete to delete, or there is a, they have at one instant they have grouped two documents into one, mention all three. So you need to see how to clearly identify, uniquely identify, and it should be clearly available. Next is the unintended use of obsolete document is prevented and suitably identification is applied to them if they are retained for any purpose. So if you say obsolete, something which is not current and no more is relevant for our activity, needs to be mentioned as an obsolete, goes without saying, and then it should be unintended use to be prevented. You need to take back all the obsolete document and provide the latest one, and should be kept as, if you want to keep it as for the information purpose or any purpose, you keep it in a different file, in a single file wherein you mention these were the obsolete documents for your information purpose, so that only the current and the right document is being used. Oops. I'm going. I've Ashutoshi, I've gone beyond it.
Not an issue, not an issue. It was just a revision and we were trying to understand the standard in a better way. Thank you very much. Thank you for your kind. Thank you very much for your kind presentation and explanation of these parts. We have the in our at 3:45. We have the panelist session. I will request you to kindly join panelist session. If there are large number of questions, we will try to reply those questions. Otherwise, what we will do, we will take all these questions and I will circulate to all the panelists. We will try to get a reply, and so that we can circulate these answers with the questions to all the participants, which will be very useful for the understanding of the standard and how they have to implement the standard in the country. So that there is a lot of confusion among the NABL assessors, among the NABL itself, that what is the meaning of this particular statement or the clause of a standard, clause of the standard. We should have at a single platform. Whether it is right or wrong, that is a different issue. But we should be at least at one platform. That is the purpose. So this is very good. Thank you very much. I would like to request you to kindly join with us and or maybe possible to continue with us. Thank you very much. Now I think there was one clause which was 6.5 that was left yesterday. So I would like to request Batra Singh ji to kindly continue this 6.5 clause.
Okay, sir. Let me start 6.5. Please share the presentation.
I'm just doing.
Yeah. क्यों नहीं आ रहा? वैसे तो यहाँ से भी दिखा रहा है शेयर कंटेंट. मैं करूँ? आपका नहीं हुआ तो?
नहीं हुआ, शेयर नहीं हुआ.
इधर से करूँ?
मैं ओपन दिस ना PDF खोल देता हूँ ना, बेटा है.
PDF खोल दूँ? कैंसिल करूँ मैं? मेरा हो रहा है.
Can't share this file because I have to know.
करूँ?
Please try.
शेयरिंग पास. फिर से खोलना पड़ेगा.
क्या है? Which one?
ये तो नहीं है. नहीं, ये नहीं है. स्टॉप शेयरिंग करो. दोबारा शेयर करो. विंडो भी जाओ। इसमें करो, हो सकता है इसमें मिल जाए। लगी तो गई है। पहले कहाँ से है?
हाँ 100% सारा है।
स्टॉक शेयरिंग करना, स्टॉक शेयरिंग करो ना, हमें तो 6.5 चाहिए ना।
मैं स्टैंडर्ड कर रहा हूँ उसका।
स्टैंडर्ड कर दो। देखो इसमें आएगा शायद।
आप करना है?
नहीं हो रहा। स्टैंडर्ड से देख के बोलिए।
संतोष जी, we are not able to share the files. अतुल जी,
सर आप शेयर कर रहे हैं या अतुल सर शेयर कर रहे हैं फाइल?
दोनों में से कोई भी शेयर नहीं कर पा रहा है।
नहीं, अभी तो उनकी शेयर थी सर, इसलिए मैंने उनको राइट दे रखा है ना। आप सब एक सीट पे बैठे हुए हैं अलग अलग
हाँ।
लॉगिन से, तो
एक
अगर
मिनट,
आप शेयर करते हैं तो मैं आपको राइट दे देता हूँ।
हाँ ठीक है, एक मिनट के मैं देखता हूँ, मेरे पास आ रहा है नहीं ना।
नहीं, अभी आपको
आपको
राइट नहीं है ना परमिशन, अभी मैं आपको राइट दे देता हूँ।
मुझे दे दीजिए, हाँ एक मिनट।
ठीक। हाँ सर, आप शेयर करना सर।
सॉरी,
अब आप शेयर करना सर, आपको परमिशन है शेयर
तो
करने
कह रहा है
की।
we can't share this file because this file is not, file type is not supported for file sharing. Either convert the file to a separate format or use
नहीं
application.
नहीं, वो था पीपीटी, तो ही उस पे जाओ ना।
PPT में अब now it is okay, now it is, now अब आ रहा है, ठीक है।
But we can't share your file, sir.
Yes, now you can see, just a minute, I'm sharing.
Okay, I'm waiting. Yes, it's sharing.
हाँ हाँ हाँ, आ रहा है।
8.8.1 ना,
6.5।
Okay
अब
sir,
होना।
fine.
just a minute.
हाँ
8.8 कर दो।
चलो छोड़ो, फिर आप यही कर दो, छोड़ो यही कर दो फिर। आ गया, बड़ा कर दो उसे बस।
ठीक है, ठीक है, ये
आ तो रहा है इसमें।
अब क्या गई?
हाँ आ रहा है ना।
ठीक है,
Yes sir,
चालू।
your screen is visible from here.
you can see the file now. Start.
Okay. So now we will discuss clause number 6.5, metrological traceability. Basically, 6.5.1 says the laboratory shall establish and maintain metrological traceability to its measurement results by means of a documented unbroken chain of calibration, each contributing the measurement uncertainty, linking them to an appropriate reference. The meaning of this metrological traceability means that a unbroken chain of calibration which is reaching to the SI unit. For example, you are having some reference standard which is calibrated by some NABL accredited lab. Then NABL accredited lab may have got this particular calibration from some other laboratory, and ultimately it is reaching to the NMI. NMI means the National Meteorological Institute of India or of any other country, and which are ultimately reaching to the SI units. So this is the meaning of this meteorological traceability. So next. क्या हुआ नहीं हो रहा? रुको रुको, शेयर हो रहा है, आगे चलो। आगे नहीं जा रहा, उससे कर्सर से दूसरी स्लाइड पे वो करो ना, इधर 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 करो ना। हाँ आ गया ना, आ तो गया।
आगे
हाँ उसके बाद ही आया ना, 6.5.1 के बाद ही आया ना। अच्छा, देन 6.5.2। यार क्या कर रहे हो?
थैंक यू वेरी मच।
The laboratory shall ensure that measurement results are traceable to the international system of SI units through. Basically, there are three means of getting the traceability. Number one is that you are getting your reference standard calibrated by the NMI, National Metrological Institute, which is in India for physical standards, National Physical Laboratory. And second thing is that from the accredited lab, accredited by accreditation body as per 17025. And there are certain parameters where direct traceability is not available. In that case, you can use certified reference materials, because where the direct traceability to the SI unit is not available, it is not possible. In that case, the certified reference material can be used, and the certified reference materials are those materials which are produced by the competent laboratory. What is the meaning of competent laboratory? The meaning of competent laboratory is that the particular laboratory is accredited as per 17034. If the laboratory is accredited as per 17034, the laboratory will be considered as competent, and what material they are producing, they will considered as certified reference material. The difference between certified reference material and reference material is the certified reference material is having the uncertainty associated with a particular value. For example, if you are having a pH value of 7 and you are having the solution of pH value, it must contain the uncertainty. So this is the basic difference between the certified reference material and reference material. And thirdly, I have already told you that you can have a traceability from the accredited lab. सर आगे चलना सर. आगे चलो बस. 3 बस इस पे चलो. हाँ. When metrological traceability to the SI unit is not technically possible, the laboratory shall demonstrate metrological traceability to the appropriate reference, such as I have already explained certified reference value or material produced by the competent producer. Competent means a accredited laboratory as per 17034. The result of reference measurement producers specified method or consensus standard that are clearly described and accepted as providing measurement results fit for their intended use and ensured by suitable comparison. Sometimes there is no traceability, it is not possible to get the traceability traceable to SI unit, and the certified reference materials are also not available. In that case, there can be a comparison between the two competent laboratories, and then they can use that particular comparison as a certified reference value. Sir, आगे देखना sir. So this was basically about the metrological traceability. I have already explained you that there are three ways. One is direct traceability from NMI or from certified reference material or by the accredited laboratory. Thank you very much.
Thank you, sir. Thank you very much. Now, actually, this was the small class which was left yesterday. So we thought that it should also be completed as soon as we got the time. Now, sir, we have with us Professor Warren Walker from Standards Coordination Office, USA, NIST USA. Sir, Professor Sir, you are here with us. Professor Merkel, you are with us.
Can you hear me okay?
Yes, sir, we can hear you. Thank you very much, sir. Thank you for joining us. Sir, first of all, I would like to introduce Professor Warren Walker. He serves as a leader of the Standard Services Group in the Standards Coordination Office of National Institute of Standards and Technology, NIST, USA. His programs under his responsibility include engagement with government agencies on standards and conformity assessment, issues and education, operation of the WTO technical barriers to trade inquiry point for the United States, and designation of conformity assessment bodies for government-to-government agreements in telecommunications. As we are very well aware that in telecommunications, whenever you are going to put a tower or you are just having the signals transferred from one country to the other country, it's a very important topic. And in India also, we are working on the dissemination of time. Very soon, maybe India has its own inter-Indian standard time. Thank you very much, sir. Professor Merkel served as a co-convener for ISO CASCO working groups on the revision of 17025-2017 for the general requirements for the competence of testing and calibration laboratories, and for 17060-2022, which is conformity assessment code of good practice. Prior to his current position, Professor Merkel was chief of the National Voluntary Laboratory Accreditation Program at NIST. After leaving NIST for 6 years to teach chemistry, he returned to serve as chief of NVLAP from 2012 to 2015. From this 1996 to 2003, Professor Merkel was employed by the American Association for Laboratory Association, most recently as technical manager. From 1992-96, he worked as investigative chemist in the Defense Logistic Agency Analytical Product Testing Center in PA. Mr. Merkel holds a BS in chemistry from Temple University and a MA in curriculum and instruction from Bloomberg University, USA. Thank you very much, sir, for giving us this opportunity, and thank you, sir. We will be always thankful to you for giving this your precious time on this Sunday. I understand you must be having 5:30 in the morning, and you are fresh, and I think you are ready for just help us. In our country, we are having large number of laboratories, large number of government officers, and the industries who wants to take the help from you. Many officers are just giving this lecture to their participants, to their industries. Many of us are attached right now, linked with us. Sir, I would like to share to you now. Over to you, sir. Kindly explain whatsoever requested by you, sir. Please.
Thank you very much for that kind introduction. It's always a pleasure to work together with our legal metrology colleagues in other countries around the world. Certainly, we value the strong connection with India. And I pass along my regards to you, as well as to Director Dixit from Dr. Chuck Ehrlich, who is our international legal metrology expert at NIST. And I coordinated with him and let him know that I would be speaking to this group today. And we're both excited that we can provide this opportunity. So if it's okay, I have some slides to share. Let me pull that up and make sure that you're able to see.
Yes, sir, we are able to see. Thank you, sir. It is okay. Visible, sir.
Great. Then I will have one question, and then I will begin. I'll hold questions to the end. I believe in the agenda we have some time for all of us to answer questions. So if that's the most appropriate, then I will hold questions till the end. Does that make sense?
Yes, sir. Please.
Okay. Great. Well, thanks again for the opportunity. I was asked to cover a few of the clauses and concepts in 17025, and if I'm looking at the agenda properly, I think I'm towards the end. So some of these may have already been touched on in some other discussions that you've had, but I'll start with selection, verification, and validation of methods. I'll speak to actions to address risks and opportunities, and then finish with decision rules, which covers multiple clauses in the standard. So let's start, and then we'll do questions. So let's start with selection, verification, and validation of methods. There's a lot of text in the standard on this, and I'll try and digest it into a few key concepts. I'll start by saying every laboratory that implements 17025 has to do method selection, whether they are given the method by a customer or whether they choose the method based on available information and materials. That selection process always happens. And to demonstrate that the laboratory can properly perform the method as it's written, all laboratories also have to do verification. They have to verify that they're following the method properly. Validation only happens if the laboratory creates or modifies a method. So as you're looking at the standard, if you do not create your own methods, if you only perform the methods as published, then validation is not something that you would have to perform in your laboratory. And that verification and validation is a critical term not only to methods, but in other aspects of conformity assessment as well. So I wanted to start with that broad statement. The standard defines method selection and gives a preference for methods that are published in standards by reputable technical organizations or relevant scientific texts. And so if the customer does not define the method, then the laboratory has some options to select methods that meet these characteristics and then not necessarily have to do additional validation. The validation has been done by the developer. If it's a standard, say an ISO standard, then the process of method development and standards development should include that validation process. If the lab then develops its own method, the standard requires that to be a planned activity. A plan requires some documentation, some thought, and a process that's defined, and that plan has to be assigned to competent personnel equipped with adequate resources. That means that method development is a different level of technical expertise than just following a method. You need to understand as you're building the method what the implications are for the decisions you make in developing that method. And so in the process, there's a sequence of steps in the plan that requires resources and competence that may be different than other laboratory personnel. Now we've selected a method. Verification is the lab demonstrating that it can properly perform the method, ensuring that it can achieve the required performance. So in looking at verification, what that means is within the method, there may be parameters or quality requirements that repeatability or reproducibility among different analysts in a laboratory or between laboratories have to be met within a tolerance. And so verification is a lab demonstrating to the extent that it can that it's properly performing the method. I was just listening to the information on metrological traceability and establishing traceability and the use of materials that have uncertainty stated. Use of those types of materials, use of quality control materials and other practices can help with verification that a method is being performed properly. And then finally, validation itself is when the lab determines not only is the method being done properly, but it's fit for purpose for the intended use, that the customer's needs and the laboratory's needs are being met by the method that's being put into place, whether the lab's developing it itself or if the lab is modifying a method to meet particular needs. As I mentioned before, all labs select, all labs verify. Validation is only required if the laboratory uses a non-standard method, if the lab develops its own methods, or standard methods that are modified. So in a chemistry laboratory, a test method may be for analyzing certain metallic components. Let's say it's a drinking water laboratory, and you have a test method that's for lead in the drinking water, but you want to use elements of that same method for a different metallic contaminant. You would need to validate that the method that you're using is appropriate for those other contaminants by using reference materials, by doing interlaboratory comparisons and so on to validate that the method as being modified is appropriate for that particular use. The standard also says that validation needs to be as extensive as necessary to meet the needs of the given application or field. So there's some flexibility in the level of rigor required in that validation process, depending on what the objectives are. If the specifications or the objectives for the customer are quite tight tolerances, then a lot of work may be needed for validation. If it's a more open tolerance, or it's a less rigorous analytical need, then perhaps the validation may not need to be as extensive. So I spent a lot of time just explaining the concepts. I'll go briefly through some of the key elements of the text then. Again, the laboratory shall use appropriate methods and procedures for all laboratory activities. Earlier in your sessions, and I'll just re-emphasize here, I would imagine that you spoke about the use of the term laboratory activities in the standard as defined in the terms and definitions as meaning testing, calibration, or sampling. So for any of those three, the laboratory shall use appropriate methods and procedures for all of them. Something in particular when we're talking about legal metrology, well, metrology in general, often the term method is used differently in metrology than it is testing. And so there was a note added here to clarify that when we say method, it's also synonymous with measurement procedure in the VIM, the Guide 99, which is the international vocabulary for metrology. In testing, it's more well understood that it's more of a procedure, whereas in metrology, sometimes when we talk about a method, it's more like the methodology. So we're talking about the actual measurement procedure here. All of this information shall be kept up to date, readily available to those that need it. The laboratory shall ensure that it's using the latest, most valid version of a method, unless it's not appropriate. In some cases, certainly in the United States, we have regulators or customers who have not updated their requirements to the newest version. And as long as that's still appropriate, and that method that's outdated is still valid in terms of the output of the method itself, then that's certainly still appropriate. And then here's a note that gives more details around the sources of different information as well. This looks like a duplicate of that slide, apologies. So along the way, as you've been looking through the standard, I'm sure you've seen different places where you need to have the procedures and then you retain records. So when verification is done, and remember, all laboratories do verification, records shall be retained. So you can't just say that we are performing the method properly. You have to have records to demonstrate that you did that verification. Jumping ahead, when that method development is required, as I said, it has to be planned, assigned to competent personnel with the level of expertise to actually develop methods, not just to follow them, and they have to have the resources to do so. As that method development proceeds, it requires periodic review. Make sure that you're following the plan and the plan is still getting the appropriate results. Once you have all of the method selected, verified, then you have to follow it. And if there are deviations from the methods, they shall only occur if it's been documented, it's technically justified, someone with responsibility has authorized that deviation, and the customer accepts it. You've done all of this work to select, to verify, and to validate. But if you change it, then perhaps that change could influence all of that activity. And that's why it's so important to pay attention to deviations. Okay, I want to jump a little bit ahead into validation. We've talked about what validation is. Just to close with the fact that for validation, there's also record retention required. The validation procedure that was used, not just the test procedure, but the validation process and plan that was used, what requirements and specifications were used to determine that the validation is appropriate, evidence that you've determined those performance characteristics, the results obtained of that validation, and then a final statement of the validity of the method. All of these activities have been done. The laboratory finds that this method is valid and fit for the intended use. That was all that I had to say on method selection, verification, and validation. Again, wanted to emphasize that there are elements of that clause that every laboratory has to do, and there are elements of the clause that only apply if you change a method or develop methods yourself. Okay, the next topic that I was asked to speak to is risks and opportunities. So I want to address, first of all, this is a topic that has multiple places in the standard that the term risk is used. In clause 414 and in the general requirements that you probably covered yesterday, there are mention of risks to impartiality. And there's examples in the standard of different potential risks to the impartiality of the lab. There's in clause 7.8.6 list the level of risk associated with the decision rule. I'm going to talk about decision rules after we go through risk, so we'll talk about that in more detail. Actions taken for non-conforming work are to be based upon risk levels established by the laboratory. Of course, I'll get into all of the clause 8.5 actually on actions to address risks and opportunities. And then it shows up in other clauses of the management system requirements, 8.7 on risks and opportunities for corrective action and management review. So the term risk shows up in different contexts throughout the standard. So let's look at that clause 8.5. Couple key things that I want to highlight here. The laboratory shall consider the risks and opportunities associated with the laboratory activities. So two things I want to emphasize. The word consider is not one that we use elsewhere in the standard. So this is a word that means the laboratory has to think about it. It has to identify and put some analysis around those risks, but also related to the laboratory activities. So it's linking the risk to the testing, calibration, sampling. That consideration has to give assurance to manage that the management system is operating properly. Is that risk something that we need to address in our management system? Will that risk enhance our opportunities to achieve the purpose and objectives of the laboratory? Is there an opportunity for us to do a better job, to expand our scope of work, or provide better service to our customers? Is this a risk that's going to prevent us or reduce the impacts of potential failures in the laboratory activities? When we consider this risk, if we were to take action, would it reduce the possibility that we would have failures or problems in the future? I want to highlight that one in particular because that shows up elsewhere when we talk about non-conforming work, talk about corrective action, and we talk about management review. This is one of the key considerations for risks in particular. You're looking at the risk for the laboratory activity, and if taking action provides the opportunity to prevent or reduce those failures, that's one of the areas where taking the actions are really important, because that's then going to hopefully prevent problems before they start. And then, of course, looking at opportunities in particular, but risks as well, provides an opportunity to improve. The next clause, this is also a planned activity. So the laboratory shall have a plan to for all of the actions to address the risks and opportunities. However, I want to stop here for a minute. This is often a misunderstood part of the standard. What this says is the lab has to plan when it decides to take action. The previous clause says consider all of the risks. So you may come up with a list of 10, 20, 30 potential risks, several other opportunities. When the laboratory thinks about those risks and decides this risk requires action, it will help us prevent a possible failure. Then the laboratory puts the plan in place to take those actions. If the laboratory considers the risk and decides that action is not necessary, there's no plan required. So if the lab plans those actions, they plan how to integrate and implement the actions into the management system. That's the purpose for the documentation, to ensure that the actions that you're taking become part of the way the laboratory operates and documents its systems for the lab. And then after the actions are taken, the laboratory has to plan how they're going to evaluate whether those actions were effective. Again, that integration into the management system and the evaluation of effectiveness, that's giving information about what should be in that plan. How are we going to do it? How is it going to become part of our management system, part of our daily routines? And then how do we know that the actions were effective? I include the note here as well that this talks about plans for actions, but there's no requirement for a formal risk management method to be implemented. In other words, whatever actions are planned by an individual laboratory, the mechanism that they use, the way they consider the risks is up to the laboratory. And there are other standards out there. There's some of the bibliography of the standard that provide risk management approaches, but there's no requirement for those formal systems to be put into place. Finally, then, with the actions taken, they are to be proportional to the potential impact on the validity of the results. Remember, these risks and opportunities are related to the laboratory activities, sampling, testing, calibration. And so the level of work done to take action should be relevant to the potential impact. Issues that could have a serious impact on results should have a lot of action taken. Things that are minor or less impactful, the actions may not be necessary or they may be less intense. The note gives examples of actions that you could take. Avoiding threats. You could take risk intentionally. You understand that there's a risk and you accept that risk and mitigate it as best as possible. And then again, there's a note that gives some context to opportunities being opportunities to expand the scope of activities, have new customers, or meet their needs better. I want to emphasize again, before I leave the text in 8.5, potential impact on laboratory results. So don't go crazy with trying to identify too many risks. Look at those risks that have the most potential impact on the validity of your results. Now, before I leave this topic altogether, I know that you've already covered corrective action, clause 8.7, but I just want to highlight again that there's this language in there about evaluating the need for action in corrective action in order that there is not going to be recurrence elsewhere. That's that whole impact on the laboratory's results. And that's a risk-based decision, even though the word risk doesn't show up in that line, but it does show up later that you need to update your risks and opportunities during planning if necessary. You take corrective action for a nonconformity, and then you identify, we missed this risk. We didn't fully understand that there was a risk associated with this particular activity. We had a nonconforming situation, we corrected it. Now let's go back and reconsider that risk. And so that really, from my perspective, has, for when I talk to laboratories, that's really the gateway to considering risk effectively. Because if you get to the point of corrective action, something happened that you needed to correct. And so you can go back and look at how you considered the associated risks and reconsider, have that discussion about, will this happen again? Do we need to address this risk differently based on the corrective action we just had to take? So that's risks and opportunities. The last clause that I was asked to talk about, the concept of decision rules. And this is a big one in metrology, certainly. It's a big one in certain areas of testing. So let's start with the definition of a decision rule. It's a rule that describes how measurement uncertainty is accounted for, when stating conformity with a specified requirement. So there's a lot there. In the definition, you have to have a specified requirement. It could be a specification limit, it could be a range, but if you don't have a defined quantitative specified requirement, then you can't implement a decision rule because you need something to use as the limits when you're considering the uncertainty. Now, taking a step back, that also means you need to have an established measurement uncertainty value for the results that are going to be subject to this decision rule. So there's a lot there. It has to be a measurement that has an uncertainty stated, and you have to have a specified requirement for comparison. So this concept of decision rules shows up in two significant places in the standard. The first is when you as the laboratory review the requests, tenders, or contracts for work. And I know that you've already gone through this clause as well. So here's the language from that clause. When the customer requests a statement of conformity, and it gives examples, pass, fail, in or out of tolerance, then at that point, as you're looking at the contract, before you do any work, the specification or standard and the decision rule shall be clearly defined. Unless the decision rule is inherent in the requested specification or standard, that rule has to be selected, has to be communicated to and agreed with the customer. So there's a lot in there. But the point is, this is a critical part of defining how the uncertainty will be addressed. And it's most important when you're close to a limit. If your result is really close to being considered pass or fail, that's when the uncertainty matters. And you want to have that agreement with the customer before you do the work. Having that conversation after the work is done and trying to rectify the results as being pass or fail or in or out of tolerance after you've done the testing is a really bad situation to be in, because it introduces the possibility of misunderstanding or different expectations of the customer and you as the laboratory. So let's talk about this. I know you're all metrology experts. I am not, but this helps. Sometimes pictures help me to understand this. So let's say we have a result. You've already talked about measurement uncertainty. Typically, the uncertainty is an expression of a range of potential values, right? And there's some statistical rigor behind that. So I'm going to express results as the blue square, if the color's coming through on your screen, with some error bars or some range of uncertainty in values that could potentially exist. So then we have our specification limit, and it doesn't matter. It has to be a quantitative amount, but for the purposes of this illustration, it could be an upper limit or it could be a lower limit. It doesn't really matter. But if you have a measurement and the range of potential values based on the calculated uncertainty is clearly not close to the limit, that's an easy decision to make. On your screen, if it's to the left of the line, and that's good, this is an easy one to call a pass. If to the left of the line is too low, it's an easy one to say that it fails. There's no issue here. It's a pretty straightforward determination. The decision rule is not going to come into effect. Same thing here. If the result is clearly on the other side of the line, then that could clearly be a pass or a fail. This is where it gets interesting, right? This is where the result itself is to one side of the line, but if you were to perform that measurement multiple times, some of the results that you get based on your analysis of uncertainty could be on the other side of the line. Now what do you do? Or here's the same example, but to the other side of the line. Or there's this case where the expansion of the expanded uncertainty just hits the specification limit. So I'll go back to the illustration. I clicked a little too quickly there. There's lots of situations where then this becomes an issue. How are you going to deal with those situations where here the uncertainty covers the specification limit, or the uncertainty is right up against the specification limit. What are you going to do? And again, that's a conversation to have with the customer before you get to that problem, not after you've measured that result and you go back and say the results are indeterminate. You need to have that discussion up front and define that decision rule. In the previous version of the standard, we didn't cover decision rules or uncertainty's effect on results until the clause on reporting of results. So that's why we added that text to the earlier contract review requirements, so that it's clear that this discussion has to happen with the customer up front. But the key technical elements of this then show up in clause 7.8 on reporting, again, which you've already probably covered. So let's look at that specifically. When that statement of conformity to a specification or standard is provided, the lab has to document. That's documentation. So there's records associated with that, some procedure around how it was done, taking into account the level of risks such as false accept or false reject, or statistical assumptions that are associated with that decision rule, and apply the decision rule. So think about the illustration that I had. In those cases where the uncertainty is crossing the line, but the result is on one side, if you decide to say, based on that uncertainty, we're going to fail that result. If you did the result multiple times, you may have some that pass. So that's a false reject. You could be failing something that might pass, or vice versa. You may be passing something that could fail based on your consideration of the uncertainty. And so there's an element of this that you need to think about in terms of risks that you as a laboratory and the customer are taking by implementing that decision rule. Where the decision rule is coming from the customer, or in many cases with legal metrology, it's built into the rules, it's built into the regulations, the specifications for the measuring devices, then the further consideration of risk is not necessary. It's kind of like with methods and method validation. If the legal authority has determined that if you follow this method and the results are handled this way and reported appropriately, then the risk has been taken into account by defining that specification. That gives the laboratory and the customer a little less responsibility for risk assessment because it's already been done as part of the development of the specification. Then, once you've got that identified, this is really important in the report itself. The laboratory shall report such that in the statement in the report, which results relate to the statement of conformity. So you can't just say pass. It has to be these measured results that we have, that we obtain through our laboratory process. These are the measurements. These are the results that were used to make the statement of conformity. This is the specification or standards that were met or not met. It's really important here when it's only part of a given standard. There are many cases where you're given a number of potential specifications within a document. A standard has lots of tolerances for different elements. I think about combining these two. If you have a set of gauge blocks, then within a set, you may be, as the laboratory, calibrating the whole set. But each individual block has a measurement, and there's a determination for each individual block that it's in or out of specification for the metrological specification you're given. I would assume the same would be true for mass sets, the same thing, that there are individual masses perhaps all on the same report. And then the decision rule is applied, actually, unless it's inherent in the request. So you have to have it, you have to report which results, you have to identify the specification, and then ultimately you have to apply the decision rule. And if you decide it up front, in those cases where the uncertainty is close to a limit, you will call it pass or fail, then you actually have to apply the decision rule as you defined it. You can't change that when you get to the reporting stage. So I think that's everything that I had. I think I had 30 minutes, so I'm pretty close to that. I see that there's some information in the chat. I apologize. Is it okay if I address some of that directly, or would you like to wait till
we have sufficient time, sir. You please kindly continue, and we'll take the question answer in the end. You have about half an hour.
Okay. Okay, great.
Please.
So yeah, well, I mean, that was all of that I wanted to cover specifically in the standard. So I'll look through the chat questions, and then perhaps I'll bring it back to you.
Okay.
So uncertainties of solid certified reference materials like potassium dichromate will be in a purity form. I believe that's true. I'm not an expert, but certainly there are cases where the specification of the content of a reference material, it can be done both ways. It could be as a percentage of the component in a larger sample, or it could be as a purity. So it's 99 point something percent pure, or there's less than a certain amount of impurity. So I would agree with that, generally speaking, recognizing I'm not an expert. I'm not sure that there was a question about, I will share the slides with the organizers as a PDF following the session.
Please, sir.
Okay. And then
Sir,
it's okay. And then the next one that I see is how does NIST make certified reference materials cost effective, as the expiry date mentioned is 12 months after the opening within its shelf life period? That's always a concern. And when I joined the session and you were talking about metrological traceability, there was a reference to 17034, and it's a difficult situation for NIST as a reference material producer that meets 17034 to establish an effective period for the reasonable stability for the material. And so for some materials, if exposure to the environment could change the value, could change the uncertainties. And remember, you're using those reference materials probably for calibration, maybe for method validation. Then as a 17034 implementing organization, we have to have information that informs a decision on the stability of the material. And so if the data that we have indicate that we can only guarantee or provide confidence in those assigned values for 12 months, I recognize that it's not cost effective necessarily for laboratories who may not use all of that material within 12 months. What I would say is, I know in India as well as the United States, there's a secondary reference material market. There are producers that take the materials that they get from NIST or NPL or other NMIs around the world, and then make materials that are of the same analytes or the same characteristics, but perhaps with larger uncertainties because their analysis is less rigorous or they're using larger batches of material. And so in that case, there may be a different alternative for the intended use of that particular material. Okay. And then I think there was a comment while I was showing the illustration that yes, if a result is near the borderline, then the purpose of the decision rule is to specify what decisions will be made relative to the uncertainty close to the limit. Looking at that, I didn't bring it up in the discussion, but in the United States, the question comes up sometimes when I do this training: can the decision rule be to ignore the uncertainty? In other words, just consider what the measured value is and not think about the uncertainty with respect to the limit. And my answer to that is, based on 17025, it's probably acceptable. If the customer accepts it, You as the laboratory accept it, and there's the bit in the standard about the request from the customer does not affect the integrity of the laboratory. And that's the decision you have to make when coming up with the uncertainty, the decision rule is this a reasonable way to address uncertainty in this case? I will tell you that in the US, I deal with a lot of regulators, and in certain industries, that is the decision rule that they take. But it's an informed decision because they understand that the specifications that they have established have already accounted for the potential uncertainty that comes from the measurement itself. An example that comes to mind for me is in our dairy industry. To define some products as butter, there has to be a certain percentage of fat to call it butter. And there's an established test method. There's no measurement uncertainty. If you follow that method, you've validated the method, then based on that, you have demonstrated that it either passes or fails based solely on the result that you get. Okay, a couple other questions have come in.
Sir,
Is it
we
still
have
okay?
questions and question answers also, question answer clause also, sir. We have some questions.
Okay.
Sir,
So-
it is, can I read, sir?
Yeah, of course.
Sir, clause 7.7.1, all points A to K has to be followed strictly, or we can be select, which is required as per our laboratory practice.
7 points. I'm referring to my copy of the standard. That's what I'm looking down at. Let me first stop sharing my screen because I don't think we need to have that up there. Okay.
So,
7 points.
Sir, these questions are mentioned in the chat. After the chat box, there is another box which is for question and answers.
Okay. Great.
Sir, we have with us the Director of the Legal Metrology, Government of India, who is the CIML member, Mr. B.N. Dikshit with us. As
Very,
we-
very,
yeah.
yeah, very nice to see you, and thank you very much for the opportunity to be
And
here
sir,
today.
we know Mr. Chuck very well. We have met with him in many meetings.
Good morning.
Yes.
Good morning.
Yes.
Sir.
Okay.
Sir.
So-
Welcome, sir. Sorry to
Yes.
interrupt you. Sir, myself, Bhattal Singh, sir. Good morning, sir. Your student. Did you remember, sir?
I'm sorry?
Sir, myself, Bhattal Singh.
Ah, yes. Yes.
Good morning, sir. How are you?
I am quite well. How are you? That was a long time ago. That was probably close to 30 years ago.
3 years, sir. 2018. You were the faculty in Guatemala.
Yes, yes, yes.
I was one of your students, sir.
Yes, I remember that quite well. Good to see you again. Yes.
Really, sir. Thank you so much, sir, for giving us your precious time, sir.
Oh, it's a pleasure. It is a pleasure, and it's great to see so many participants.
Yes, so we have large number of
in the meeting.
participants. Yes, sir. Sir, they are not only the legal metrology, but they are the accredited laboratories in the country.
Excellent, excellent.
So, sir, now
Oh,
the
right.
question is.
Yes. So back to 771. When looking at all of those, it's only to, and this is language that's used throughout the standard. So I don't know how much you've discussed this as you've gone through, but it says the monitoring shall be planned and reviewed and shall include where appropriate. And that where appropriate means you don't have to do all of them A through K. You use those activities that are appropriate for your validation. So it may be appropriate. A is to use reference materials or quality control materials. So I mentioned that. If you have them, if they are not available, then it would not be appropriate to use them. You may not have alternative instrumentation. You may not be able to do functional checks and so on. And so all of these are possible ways to perform that, ensure the validity of your results, but they are not something that you have to do all of them if you don't have the availability of those resources. Okay.
Thank you, sir. Thank you. Sir, another question is, if a laboratory select method from IEC or ISO standard and following requirement by these ISO IEC standard, in that case, validation or verification of the method required or not?
So I would say generally validation is not required. So you don't have to determine if it's fit for purpose. You do have to do verification. You do have to demonstrate that you can follow that method appropriately and get results that are within any specified tolerances. So as I mentioned, you always select and you always have to verify that you are performing the method properly. And that the depth of that verification may not be too extensive, but you would not need to necessarily validate.
Okay, thank you very much, sir. Sir, is it mandatory to give the statement of conformity in all calibration certificates?
From my perspective, no. There are two possibilities. One is that the customer wants you to, and that's where that discussion under contract review becomes part of the issue. And then possibly, and you all are more expert at this than I, but there may be certain standards or specifications that require that determination to be made if you're going to follow the method. So if you're going to determine that weights meet a certain class, then by definition, you're actually doing a statement of conformity by saying it meets the class or not. And so that would be the only exceptions where it's inherent in the specification itself that you're making a statement of conformity or not.
Okay, thank you, sir. The next question is, sir.
So, very nice to hear Dr. Warren Markel from NIST. So, during the CIML meeting, we get opportunity to meet the NIST officers, and I'm very happy that you came to these very programs and made this program very successful. And I think the participants are very happy to hear you. And there are a lot of the questions were resolved only by your lecture. So it was not required to ask you the very further the questions or repetition of the questions like that, because you are very clear regarding the verification and the validity and the laboratory requirement and what are the how the validation should be made and what is the customer requirement. So I think in India, people are not thinking for the customer requirements and then validation angle in that very respect. And we are much worried about our laboratory respect, and that way we are maintaining the standards and all that very things. So we should think that what is the customer's requirement, and accordingly we should issue the certificate. We should not think regarding the validations and other things of our laboratory. We should think for the customer's requirement and what is the they have their laboratory and metrological requirements, because that varies from customer to customers. Some are very sophisticated, some are not having. So like you have the bread measurement, you have sometimes the bent measurement, and so many type of things are there. And sometimes it is from the medical side, so the meteorological requirement is very precision and all that type of things are there. So this way I am and my teams is very grateful to hear you, and I hope that you will always participate in our programs and Indian side will also get opportunity to learn some of the things from your side. Lot of thanks, sir. Lot of thanks to hear you. Lot
Thank
of
you very much,
thanks,
sir.
Mr.
Thank you. Sir, there is one another small question from the participants that some of them are doing the ILC, inter-laboratory comparisons, whether if a laboratory is performing inter-laboratory comparisons, they have to perform proficiency testing also, or the ILC will be sufficient?
That's an interesting question. From the standpoint of the standard, I would say that interlaboratory comparisons would be sufficient for demonstrating conformity with the standard. But I'm very careful when I say that accreditation requirements usually require something more than that. Usually, proficiency testing is required, and there's a distinct difference there. Excuse me, in the definition, right? An interlaboratory comparison is when different laboratories perform the testing or the calibration on the same or similar samples under the same conditions. And then they look at the results. And that's really valuable because you can identify when there are potential differences. But a proficiency test, the definition of a proficiency test goes a step further and says that there are specified ways of determining performance. And so that is really important then for accreditation purposes, because it's a way to not only see that the laboratories are operating consistently, but there's an analysis of whether their results are meeting expectations, whether they're close to an established reference value or close to some sort of statistical analysis of the overall participants. And so that's the difference with proficiency testing. From the standpoint of the standard when we wrote it, the key was there are two elements of determining that your results, two potential ways to determine the validity of your results. There's what you do inside your lab, and we just talked about that list. That's in your control. You do it every day. You may be doing control charts and other ways to show that within your laboratory, as best you can tell, you get good results. However, and particularly those of you in metrology, you still need, even at the highest level, we at NIST compare with our colleagues there in India and around the world to make sure that our system isn't drifting differently than somebody else's, that we still have that traceability to the SI. And so that's where inter-laboratory comparison provides that connection to other laboratories' results to ensure that everything is consistent. And then again, when you're dealing with results from other laboratories, seeing how you perform is valuable. A proficiency test where your performance is actually analyzed and you can determine if the results are acceptable or not acceptable is also extremely valuable.
Thank you, sir. Thank you very much. Sir, the next question is, please define the criteria for intermediate checks in ET, mass, etc. What would be the criteria for intermediate checks?
That's a more difficult question. There's nothing in the standard that defines that. It's left to the laboratory. However, it may be defined in test methods or calibration methods. It may be defined in other requirements for performing test methods. In many cases in the United States, for analytical methods that are used in food, drinking water, hazardous waste, and so on, the method itself sets requirements for the frequency of quality assurance and quality control checks. And so there may be other requirements, but from the standpoint of the standard, if there are no other requirements and you're not accredited, then it's left to you to determine. But I will say that that's a risk-based decision. That comes back to actions to address risk. The longer you take between doing verification checks, between doing instrument checks, the longer you wait to have your equipment calibrated, then the more risk you take that between those checks or between those calibrations, your instrument has gone out of specification. And so it's a risk-based decision. I'm willing to accept the risk if I validate this method once a week or once a month, because I have other ways of knowing if it's drifting. Versus, it's so critical that I'm going, and we do this at NIST when we are doing calibrations, because the uncertainties are so low, they will do a full verification and validation of the equipment every single time. That's not efficient. It's very expensive, but it's necessary to have the level of uncertainty that we need. In a laboratory that's working for generating results with perhaps less uncertainty required, then they may have longer intervals between those checks.
Thank you, sir. Thank you very much. Sir, the next question is how to report qualitative measurements. Example, E-coil absent or present with measurement uncertainty as per ISO guide.
That's a difficult one, and I don't want to get too far out, and it's a bit outside of my expertise. I would say that there's recent, I think, publications on dealing with uncertainty for semi-quantitative or non-quantitative measurements. And I will unfortunately have to point you to the different guidance that's out there. I'm not an expert in that. I know that we are addressing that quite rigorously in the US at NIST right now in areas related to forensic science. So when we're determining the characteristics of materials that were part of a crime, and often it could be presence or absence of a controlled substance like a drug. It could be matching patterns from one object to another. And so there are quantitative elements in that measurement, but it does come down to qualitative presence absence or match or not match. And again, we're working hard on providing some statistical and uncertainty rigor around that. But I unfortunately can't give a definitive answer as I'm not an expert.
Okay, thank you, sir. Sir, the next question is, what is the frequency of verification of validated methods?
Okay, and again, I think that's similar to what I just said. Again, there's no frequency defined in the standard. So how often you repeat the verification or the validation depends on the situation in the laboratory. And there are lots of factors in that. How often do they run the method? Do they use check standards routinely? So they may not need to do the full validation if it's their own method, or repeat the full verification if they have evidence that the process is in control using reference standards or other means. And there are also maybe requirements then for accreditation purposes or in the methods themselves that would require certain activities to be done. But from the standpoint of the standard, again, that's a decision that's left to the laboratory based on how much risk they're willing to take.
Thank you, sir. Sir, we have some questions from yesterday's presentations also. If a board resolution of a company to open a lab of an existing company, whether it can be considered as a legal identity?
Ooh.
The board resolution of a company opens a lab. During the board resolution, they decide that they are going to open a lab. So the legal identity of the laboratory will be the legal identity of the company, because the name of the laboratory will be different as far as this legal identity is concerned.
Yeah, that's a difficult one that depends on, we struggled with that language in the standard because we recognize that the legal system in every country is a little different. I would say in the US, our legal system would allow for that, potentially for that laboratory to be identified as its own legal entity. And we have both situations. We have where we would consider it a first-party laboratory that is part of a larger company, and they perform tests and or calibrations on their own equipment. And then we have companies that have established a laboratory, but it's its own separate legal entity. It has its own management and leadership. It generates results under its own name and so on. So I know it can happen in the U.S. I have no experience in Indian law on whether that would be legitimate or not.
Thank you very much, sir. But in this case, will there be not the difficulty of integrity?
Oh, of course. So that's a risk to impartiality, right? It would have to be identified when dealing with customers and being ensure that information is available to customers and they understand the potential risk to impartiality there, for sure.
Yes. Thank you, sir. Thank you. Sir, next question is, do you think that the present practice of validation of methods, clause 7.2.2.1, not being addressed in the line of standard 17025 with respect to note 1?
I want to go back to the text here again. Which clause are we talking again?
So we are talking about this clause 7.2.2.1.
Okay.
The practice of validation of methods being addressed in the line of, not being addressed in the line of standard 17025 with respect to note 1.
If I understand the question correctly, then yes, I think from the standpoint of the standard, I think method validation in particular is something that laboratories struggle with, and it's because there's a difficulty, especially when the laboratory is establishing a method, to really come up with meaningful metrics for validation, ensuring that the method is actually valid, and having adequate traceable reference materials or reference standards to support that validation. So I would say that there is definitely difficulty in many cases being able to fully complete a method validation when a laboratory is developing a method or modifying one. That's why I think there's a preference in the standard to use methods that have already been through that process when the standard or the specification is being developed itself. Other multiple parties are part of the development of that method, and that method validation would be part of the publication of that standard.
Okay, thank you, sir. Sir, under this standard, somebody was saying that the first draft, first standard ISO 17025 was of 1999, but in the standard it is mentioned 2000 and then 2005 and then 2017. So is it correct, sir? It was 1999 or it was 2000, the first the standard originally published?
Well, so before that there was Guide 25, and that was from 1990, I think. I'd have to go back and look at older copies. And that's what, when I started in accreditation, that's what we used. And then, yeah, there were previous revisions, and there was a change that was made. I'd have to go back through and look at the exact dates. But one of those intermediate changes after 2000 was to align 17025 with ISO 9000 2000. And so when we make reference in this version to ISO 9001 as a basis for the management system requirements. And that's always been a strong connection with this standard. And so after 17025, the standard, that designation was published, and then ISO 9001 changed not long after that. There was an interest to go back and make sure that the two standards still aligned, that the quality system requirements in 17025 aligned. So it wasn't really a full revision of the standard. This revision was the first one in over a decade. Yeah.
Thank you, sir. Thank you. Sir, the next question is, what could be the option if a lab to implement a management system gets certification to ISO 9001 and self-declaration conformance to ISO IC 17025 or vice versa?
Yeah, that's an interesting question as well. I think the intent of, from ISO's perspective, and the intent of generating the standard is that it can be used in first, second, or third party conformity assessment. So in other words, it's completely legitimate for a laboratory to self-declare conformity with 17025. It's also legitimate for them to pursue certification of their management system to ISO 9001, in addition to declaring conformity with 17025. Where the requirements change then is based on customer needs or government or regulatory needs. And so that's where, in some cases, you may be required to be accredited. A customer may require you to be accredited because they want to rely on, in this case, NABL, to do the evaluation of the laboratory's conformity and competence, rather than trusting the laboratory to do it themselves. And so customers can require that of a laboratory. The government can require it. We have certain programs in the US, I believe it's true in India, where you have to be accredited. And so in that case, you can't just self-declare. You can't even rely on the certification of the management system. You actually have to be accredited to 17025 by the national accreditation body.
Thank you, sir. So the next question is,
one question from my side.
Sir,
That at the international level, I find that some of the laboratory, they say that I do not require the certification of ISO 17025 from any third party. So they declared that I am the self-competent, and you can see my laboratory, and if anything is there, you can complain for that. You can come to my laboratory and visit the things and all that very things. They invite the all type of authority and at the international levels, but they never like that their laboratory must be accredited by some authority and something like that. Even for the interlab comparison and all that type of things, they believe in the peer assessment and that type of things, but they never believe in this ISO 17025 certifications. So this is the things, and this is the new philosophy at the international level and the highest level, highest at the international level. The country who meets those very requirement and all do that very things. But it is very difficult for the developing country to do that very things. So this, if you have any remark on this issue, please tell something.
Sure. So I'll start with at the highest level, and to be clear, NIST is not accredited. There is no accreditation body in the United States that would be in a position to accredit NIST, given the type of work that we do. So NIST itself has a rigorous system of self-assessment, and the outcome of those self-assessments is reviewed by a quality system task force in the Inter-American System of Metrology. And so, yes, we have a very rigorous management system, and we also operate an accreditation program. And so we work together to ensure that the NIST quality system and the implementation of 17025 17034 and 17043, where NIST does proficiency tests, is of the highest level. That is difficult. That is difficult to demonstrate. We are always ensuring that we provide evidence to our peers around the world that they can have confidence in our laboratory. And we invite outside experts to come and evaluate as well. When you get further down, sort of down the traceability chain, then, as I mentioned before, it becomes part of the overall system of confidence that is necessary in the results. And you mentioned inter-laboratory comparisons. We have challenges with that in the US as well, because our system for accreditation is not consistent in the United States. There are large parts of our economy where the laboratories that are used are not accredited by an ILAC signatory accreditation body. So probably the biggest example is construction materials. There's a whole system of accreditation that it's based on other requirements and government regulations that are similar to 17025, but not the same. And so when we do inter-laboratory comparisons on concrete or on steel associated with construction, the problem that you identified is correct, in that the laboratories participating may be accredited, may not be accredited, or they may be accredited by these other authorities. And so there is a challenge in ensuring that there's confidence in the quality of all of those results that are used, because the outcome of the proficiency test affects everyone. It affects the accredited laboratories, and it could affect their accreditation status. I think for me, and the way that I counsel regulators in the United States, it really comes down to how much responsibility you wish to take and how much you trust the entities in the system. So relying on third-party accreditation provides a mechanism to have some level of confidence in the laboratory's competence. That somebody else who's good at evaluating the competence of the laboratories has done that. That's still not a guarantee. I think we've all worked with laboratories that have been accredited that are not the best laboratories that we've seen. And we've probably all been around laboratories that for whatever reason never did get accredited, and they're the best laboratories that we've ever seen. And so it just, there's a whole collection of factors that goes into this. But one of the things that was incorporated in the standard, particularly from a metrology and traceability standpoint, is accreditation provides some level of evaluation that you can trust the traceability that's been established from that accredited calibration laboratory back to the SI. So I, as a laboratory, if I use an accredited calibration laboratory, somebody who knows about that has looked at everything upstream, and I only have to worry about my own laboratory. And I've done, the term that's used in the United States is due diligence. I've done my due diligence to ensure that I've done everything I can with respect to traceability. The standard permits that. My accreditation requirements permit that. And so I've done what's necessary. But Director Dixit, to your point, yes, it's a challenge everywhere. It's a challenge here in the United States as well.
Thank you, sir. Thank you very much, sir. Sir, there are some other questions. How to do intermediate checks for standards having precise accuracy if the laboratory does not have any master having higher accuracy to do intermediate check?
That's a difficult, they're really, from my perspective, and I'm not an expert, it's very difficult to do intermediate checks. So what I would say is there are ways, though, that you could potentially find gross errors. In other words, if that master that you have, when you use it, you have secondary standards that you always measure and that are kept under similar conditions. If for some reason something has gone terribly wrong with your most accurate and precise standard, you would probably pick it up using that secondary controlled standard. But you're right. Otherwise, and eventually every laboratory gets to the point where you have the highest level stuff, that you can, and then it becomes an issue of then how frequently do you need to calibrate that, and how do you handle it to minimize the risk that it's going to drift or cause problems.
Thank you, sir. Thank you, sir. There is one another question, sir. Can we perform ILC with our sister laboratory having same name of organization but different locations, having better CMC and different heads in both the laboratories?
I would say, again, from the perspective of the standard, yes, that would be an interlaboratory comparison. From the perspective of an accreditation body or other authorities, they may have a different understanding of that. But the point of those requirements in the standard is to get outside of your system. Now, the one thing that I would caution is, again, the value of this is to get an understanding of how your results compare with other laboratories. And so sometimes when there are sister laboratories, they may use the same calibration provider, they may use the same in-house corporate services for calibration. And so that's not a full separation then, because if there's a problem there, it would translate to both of the sister laboratories in a way that otherwise wouldn't if they compared with different labs.
Impartiality is the problem.
Yeah.
Okay. So we have a few other questions also.
There is no major question, sir. Only the thing is that we are mostly the metrological laboratory, and where we do the calibration of sophisticated standards of weights and measures, and sometimes these are very very accurate, and sometimes they are of medium accuracies. But the peoples used to think of from the same angle, like if we have mechanical things and if we have the digital things. Sometimes people used to think that the digitals are very accurate and mechanicals are not accurate, but the peoples never go about their accuracy and all that type of things. So people believe that this is the digital and that will be having the better accuracy and better measurement and all that things. So that takes the times to change the atmosphere and society and all that type of things are there. And this way the things are going, and wherever the inter test laboratory comparisons is there, that may be performed at the equal level if they are the reference standard laboratory, because you cannot go above to that. Above to that means you have to go at your highest metrological laboratory of your country, and everything you cannot refer there, and you cannot say that this differed, that differed, that differs, and it is matter of struggles. So we must have that our highest laboratory for the measurement purpose once a year or twice a year, and inter-laboratory testings, if it is the reference standards, may be done in the inter-laboratories among the reference standards laboratories. I think that this is the one of the best things for the inter-laboratory testings.
Absolutely.
And
Absolutely.
I cannot say for the middle class level laboratories that you have to think about the level of the laboratory where you are going for the intertest laboratories and all that type of things. This is my view for the interlaboratory testing.
Sir, now would you like to say, because sir, we have large number of laboratories in our country which are accredited by 17025, and these laboratories are working in all the fields, whether it is testing of food, medical, material, etc., and calibration of all type of standards, whether it is electronics, electrical, food, pharma, anything. So we are having large number of laboratories. What you would like to say, few words about our laboratories, how they should perform better and what they can do better? Just a few words.
Oh, okay. So I think the key message that I would want to share is that part of implementing 17025 is having a commitment to always trying to better understand the measurements that you make, and that it's a continuous process. That getting accredited, implementing 17025, that's just the beginning. And if you're using the standard properly, using the techniques for ensuring that your methods, that your measurements are valid, you're always going to be learning more, and you'll provide opportunities to improve without a lot of additional investment. It's really just paying attention to the processes that you have in place. And so that would be my overall message to all types of laboratories, and it's in the US as well. It's a huge accomplishment to put a system in place that meets 17025. And if you take that next step and get accredited, that's a tremendous accomplishment. But it's, again, only the beginning of the journey, and continue to operate the systems that you've put in place.
Thank you very much, sir. Thank you for giving us your precious time early in the morning and at a very short notice of within 2-3 days. Thank you very much. I'm always thankful to you, sir, and we will continue to take your expert advice, the brilliant advice whenever I will be holding these type of programs. We will certainly request you to come and enlighten us on this standard. Thank you very much, sir. Thank you.
It's been my pleasure. It's great to see everyone. It's great to see see you, Mr. Singh. It's been quite a while, and to those of you in the legal metrology department, again, my appreciation is quite high, and I'm more than happy to participate in future events.
Thank you very much, sir. Yesterday we were more than 500 participants appearing in this program. Today we are having large number of participants. Thank you very much, sir. We will continue to take your help. Thank you very much, sir. And sir, we will send you these question and answers to you. You just have a look of it, and if it will be okay, we will circulate it to all our laboratories.
Absolutely, for sure.
Thank you very much, sir. And kindly send me your presentation, sir, please.
I will.
Thank you very much, sir. Thank you.
Thank you,
Good day, sir. Thank you.
Thank you, sir.
Thank you. Good day, sir.
Thank you. Have a good day.
Thank you, sir. Good day, sir.
Thank you, sir. Thank you, sir.
Bye-bye.
Bye, sir. Thank you very much.
Thank you, Ashutosh.
Thank you very much, Director sir, who has given his time during this afternoon, and tomorrow morning again everybody has to rush to the office. We have utilized these Saturday and Sundays. We tried our best to get something. Even Sangeeta madam from UK, she has also maybe very morning time. US, it is around 5:30 in the morning. So everybody was trying to help the Indian industries, Indian manufacturers, Indian laboratories, and the Indian officers, how we can build the capacity building of the nation. Sir, with these words, thank you very much, everybody who has joined this program. Thank you, sir. Thank you.
Exit कर दो.